Hey guys, how's it going? I'm back here with another video, and today this is a video that I've been waiting to post for a long time. Basically, this is the whole series that I've been posting throughout the past month on my channel, where I teach you guys GraphQL from the beginning. I just posted the last episode this week, and the reason why I'm posting the series as like all the videos condensed into a single video is because I made a poll before I started the series, and I realized that it's kind of almost 50-50 the percentage of my viewers who prefer to watch series that are like a single video compared to those who prefer to watch series that are posted like in sequence. So I decided to do both, and for those who prefer to watch a big video but with all the information inside of it, this is the video I am going to post. Now the difference between this video and all the other videos combined is pretty much non-existent. If you want to check out the other videos, you can check out the links I posted in those descriptions, also the comments and any doubts that I resolved in the comment sections. But feel free to ask any questions as well while you're going through the series, because I will be answering most of the comments and any concerns that you guys have. If you're also interested in suggesting any other GraphQL topics that I didn't mention in the series, feel free to leave a comment down below and I can definitely make a video about that. I absolutely loved this series, so I'm really excited for you guys to watch it, and yeah, that's basically it. Before we get into the series, if you guys could leave a like and subscribe to my channel, I would massively appreciate it. The reason for that is because it will help push my videos to more people, and I know it doesn't seem like this will cause any effect, but since I started asking for this in the start of my videos, it actually worked, and I'm really grateful for all the support that I've been getting. So if you enjoyed the video, if you get any value from it, feel free to do that, and I would be very happy if you do so. So with that in mind, let's get into the series where I teach you guys GraphQL since the beginning. Hey guys, how's it going? I'm back here with another video, and today I decided to bring this new series, this new course that I'm bringing to the channel, where I'm going to try to teach you guys everything I believe you have to know in order to say that you've learned and understand GraphQL. So I'm going to go from the beginning, and I decided to divide the series in a way such that it's not going to be very long episodes. You can watch it whenever you want, and I'm going to have a very established chronological order where I start going over some of the basics about the language and about what exactly is GraphQL and all that kind of stuff, and then I transition more into actually building the stuff. And finally, at the end, I really hope you guys will have a really good understanding of GraphQL and just understand when you should use it and why it is important and used by many large companies. So in this first episode, I'm just going to go over some of the basics and talk a little bit about GraphQL as a whole, and also lay out exactly what will be the structure of the course. So initially, as you can see, this will be the kind of the course structure. In this video, I'm going to be talking about what is GraphQL and some of the differences between GraphQL and creating a normal REST API. I'm also going to talk about other stuffs like how to use a GraphQL API, and I'm going to show you guys a clear example on how to do that, which I hope will teach you guys at least some of the basics just to get used to the language we use with GraphQL, understand where it comes from, and start understanding the very clear differences between fetching data coming from a REST API or from a GraphQL API. And by the way, this structure isn't divided by videos. The amount of videos will be chosen later on. However, I'll try to post at least 4 times a week for this series, so that those who are watching as I'm posting don't have to wait a long time to get the next episode. The episodes will be pretty short, as I mentioned, just because I don't want to bore anyone out, and I know that if I make very long episodes, people might decide not to watch it because they don't want to commit to it. So if I make it short and simple, I really hope you guys will be able to stay focused and get as much value as possible from each episode. So I also want to talk about how to actually create a GraphQL API. And for that, I'm going to be using NodeJS, JavaScript, and Apollo Server, which is the library, the wrapper around our API for GraphQL, to serve GraphQL in our application. And when we start building that, I'm going to teach you guys a lot about the actual GraphQL language. So like what are types, queries, mutations, what are scalars, what are enums, unions, all that kind of stuff. I'm going to try to really focus on the GraphQL query language because I feel like it is something that is lacking a lot in other tutorial series around GraphQL and YouTube. And since obviously I'm not including paid courses, I want to compare this course to other courses which are also free. So I feel like this kind of information is lacking. So I really want to go over that because it becomes confusing if you don't really understand the basics of the GraphQL language. And finally, at the end of the series, we're going to fetch the data from the API we created in React. And with that, to do that, we're going to be using a very, very famous library called Apollo Client, which is used by many, many large companies, and it is probably the most famous GraphQL library in React. And I'm going to teach everything related to Apollo Client because it is another huge topic that I feel like it isn't explained enough. I'm going to be talking about all the different hooks that comes with the library, all of the different aspects of on how to fetch your data. I'm going to talk about caching, all that kind of stuff. So it is interesting. I'm really excited for this series, and I really hope you guys stick with me throughout this whole series. If you want to jump a couple episodes, you can do that too. You can jump to the episode where I talk about how to create the API and how to create the Node.js application. Or if you're just interested in learning about how to incorporate an API into React, you can just jump to the episode where I do that as well. So that's why I want to keep this series very simple and well structured so that anyone can come and watch the episodes whenever they want to refresh their skills or just want to learn something that they haven't learned in the past. So with that in mind, let's start talking about the important stuff. So what exactly is GraphQL? Well, if you searched that question on Google before, you've probably seen a very broad explanation, probably saying something like that GraphQL is a query language. And what exactly does it mean for GraphQL to be a query language? Well, many of you guys might have heard in the past that SQL is a query language, right? It is a query language, and that might imply and create this false notion that GraphQL is something related to a database, or GraphQL is a database. But that's not true at all. Query languages are not specific to databases. Query languages are used or is a programming language used to get data. May it be from a database, or in GraphQL, it will be from an API. So GraphQL exists as technically a layer in between your front end and your back end. And the client, which is the front end, will use this query language to request data from the API, and GraphQL will take that thing into consideration and will decide what to return or what to do based on that. So differently from SQL or other database languages, GraphQL exists in between the front end and the back end. And usually those query languages related to database exist in between the backend and the database. So that is a distinction that I really want to make, because I hate going online and seeing someone asking, which database do you use? Do you use GraphQL? And I don't know why I've seen that in the past. And the reason why I hate that is because it is something that I used to think. I used to see the letters QL at the end and think it was some type of SQL database. So I really want to show you guys that it isn't. And if you keep that in mind, that GraphQL queries an API and not a database, you might wonder, okay, but what aspects of, like, how does this differ from a normal request that you make to a REST API? Well, there's an interesting distinction that you need to make, which is in GraphQL, there is two types of requests, technically. There's a query and the mutation. They're not called requests, they're actually called types that exist inside of GraphQL. But every GraphQL application will have these two types, a query and a mutation. And I want you guys to think of it this way. Inside of a query will exist all of the data that you might want to request. So if you're in the front end and you want to make a request for some sort of data, you're going to make a query. And all of the logic will exist inside of the queries. So technically, we attribute that, if we're talking about, for example, the HTTP methods that you're probably used to, the get method will be specifically connected to queries in GraphQL. So whenever you hear about a query in GraphQL, think of a get request, because you're getting some data, you're querying some data that you want to receive in your front end. Now, a mutation is a bit different and a bit weird if you're not familiar with it. Just think about the notion that I mentioned that GraphQL is handling data. So mutations incorporates everything related to mutating the data, to changing the data. So for that reason, it is the same thing as a put request, a delete request, and a post request. Because everything, like if you want to update data in your API, you call a mutation. If you want to delete data in your API, you call a mutation. If you want to create data in your API, you call a mutation. But if you want to get data from your API, you call a query. This is the distinction. With GraphQL, you don't need to specify what kind of HTTP request you're making in your frontend. You just specify if you're trying to make a query or a mutation, and GraphQL will know how to handle that. And that's one of the things that I really like about it, because it abstracts all of this notion over here. But it does actually have this methods in GraphQL on its core is actually either making a GET request or a POST request. However, you really don't need to know that. Just know that you won't have to worry about what kind of requests methods you're using when you're working with GraphQL. And one thing that I really wanted to talk about, because it is something that I used to be very confused on, is as I mentioned, GraphQL can exist as a layer in between your frontend and your backend. So this over here would be the frontend. This would be the API, your backend, which let's imagine it is actually a REST API. It has a bunch of endpoints that you can make requests, right? Somewhere here would be the database, and the API communicates with the database to I don't know, put data inside of there or retrieve data, do whatever it wants with it. What happens is GraphQL can exist in two ways inside of a normal application that someone is developing. It can either be a completely different separate service from your backend, and your frontend only communicates with GraphQL, which then makes a request to your backend service, or it can exist as your backend service. And I know that's kind of confusing, but just know that the front end, if you're using GraphQL, will never make a request to an endpoint in the backend. It will never do that because the GraphQL layer exists in between them. So it will always be communicating with GraphQL. And depending on how you want to approach your project, you can either make the GraphQL layer be your backend, or you can just separate them like this. And that's what happens, I believe, with many big companies. If they want to scale their development services, they can just separate them. But you'll see many tutorials online creating an Express API which already incorporates GraphQL. And that's what we're going to be doing in this tutorial series for simplicity reasons. But I really hope that at the end as well, I will be able to show you guys a little bit of this separation. But that will be something that I will talk right at the end, so that you guys can also start understanding how a project can be structured so that it is actually separating the backend from the GraphQL layer. And immediately you can realize that it is a bit different, right? It's a bit weird. It is completely different from what people are usually used to with REST, because REST is just you make you fetch a request to your API, and you request an endpoint, you specify the method, and the API just recognizes that request and returns data, or changes the data, or does something with it. And now when I introduce GraphQL, I'm talking about this weird thing, which is a layer that exists in between them. So I understand it might seem a bit confusing in the beginning, but believe me, it gets a lot better. And I want to talk a little bit about this specifically. What exactly are the differences between a GraphQL API and a REST API? Well, the first difference is that there's only one endpoint. And that was something that I was really confused in the beginning, because think about it that way. You're used to creating like hundreds of endpoints, depending on what you want to do inside of your front end. With GraphQL, that's fixed, and that's amazing. You don't need to, the front-end developers don't need to memorize all the endpoints. They don't need to know what endpoint I need to make a request to. All of the requests will be made to a single endpoint called /GraphQL. So imagine you have an application which it needs data from a user, it needs data from the followers, and from posts or something like that, like a social media. Normally, if you're using REST, you would probably have some routes and some endpoints with this structure. But with GraphQL, all of them will be made to the single endpoint, which is the /GraphQL endpoint. And another point that is really interesting is overfetching and underfetching. And what I mean by that is, imagine that you have this beautiful profile page design that I made over here. I know it looks ugly, but just imagine it as a website. And you have here a profile page with the profile pic for the user who is logged in, and they have like a feed with all the posts that they've made. And imagine it's something like this. And in the same web page, you also have to know information about like the followers, right? So the people who follow this user. So you need their pictures and you need their names and that kind of stuff. So you have a bunch of data that you need to manage and you need to access in the front end. So in order to make that work, you can do it in either, like if you're using REST, you can either do it in two ways. And both ways have issues to it. So one way, the problem is that you're gonna find yourself overfetching data, which is the case I have over here. You can create one endpoint and you can call it something like /userinfo or /userprofile, something like that. And it returns literally everything. It returns a JSON with the user ID, their email, their name, their picture, a list of followers, and for each follower, it returns their name, their picture, their ID, that kind of stuff. And then for the posts, they probably exist in a different table as well. So you also need to return the list of all the posts. And this is kind of bad because imagine you want to fetch just the followers. But then just to fetch the followers, you also need to get the information about the posts and the information about the user in himself, which doesn't really make sense because you're fetching more data than what you're asking for. So with REST, what people usually do is they separate stuff into different endpoints. So if I only want to get info about the followers, I'll create a followers endpoint and I'll just send the data for the followers through that endpoint. And it would look something like this. I know some of the pictures might have bad quality, but you can see like for the followers, you're only gaining this kind of information. For the post, you're only getting the post information, and for the user, you're only getting the user information. However, this is kind of underfetching, right? Because when you have a situation like the page that I showed previously, you really don't want to make 3 API calls just to get that data. Each request is underfetching the information that it needs for the client, for the front end. So the problem is, with the REST architecture, we're letting the backend determine what kind of data the front end wants, which doesn't really make sense. The front end should tell the backend exactly what it wants, and the backend should just serve that data and give it back to the front end. So GraphQL kind of turns that around. It allows the front end to specify exactly what they want, and GraphQL as the language, as the layer, will allow us to do it that way, and will basically resolve everything and fix everything for us so that you're never overfetching or underfetching data. With GraphQL, you really don't, you specify what you want. So I can have all of this data over here, but in the front end, I can just specify that I only want the name, and GraphQL will only return the name. And you might think, okay, but still, the backend will have access to all of this. Isn't that bad? Well, not technically. The one of the most costly things in a website is fetching the data and downloading the data in the front end. So it's a lot better to just download a JSON with this field than downloading all of this at once. So that's kind of what GraphQL does. And if it's confusing right now, don't worry, we'll definitely see how that works and we'll use that throughout the series. And that's basically it for the first episode. I'm aware that some of the stuff that I talked about might not be very clear yet, but that's completely fine. I just want to let you guys know that if you stick with the series, you'll definitely get it after a while because we're going to be providing more hands-on examples. Next episode, we're already going to be working with the GraphQL API, and you guys will be able to see exactly how it works and how easy it is to fetch data. So I'm really excited for the next episodes. Remember that I'm going to be posting them in sequence, so you won't have to wait. And yeah, I'm really, really excited for this series. Today we're actually going to start working a little bit with the GraphQL language, as I promised in the last video. I'm going to explain some stuff like go over the basic types, also go over a little bit of how the GraphQL schema is defined, so the structure of a GraphQL schema, and also at the end I'm going to be using a public GraphQL API, as you can see over here. And with this API, we're going to be querying and fetching data using GraphQL. So I'm going to teach you guys the basics, so how to make like a basic query to an API. And if you're interested, the link for this API will be in the description. So you'll be able to go to this link over here where you can use this beautiful interface in order to make the requests. So I'm just going to open this up a little bit like this, so it becomes like full screen. So as you can see over here, I opened up this this thing over here, this website. This is actually an online version of GraphQL Playground, which is kind of like it's a software which is kind of like Postman, but for GraphQL. You can use Postman or other API testers to make GraphQL queries. However, I highly recommend using something like GraphQL Playground because it has a lot of built-in cool stuff that will help you throughout your way. So the thing is, it also exists inside of the browser, and we're going to be using GraphQL Playground later on in the series. However, for now, let's just use it like this to just test this API that I found online. So before we actually start querying the API, I'm going to go over just some of the basics, right? So some of the little small things that you need to understand about the GraphQL query language in order to get it going. So the first thing that we got to understand is GraphQL comes with 5 different like basic data types that comes with the language. Similar to like Java or other strictly typed languages, you need to define what your fields are. So there's a string, there's an int for integer, there's float for like decimals, and there's booleans for a boolean, for a true or false statement. And GraphQL, it actually only exists this 5 types over here. The ID type is because since GraphQL is a query language and IDs are so common inside of like databases or any kind of request, they created this ID type, which basically is used for IDs. So it can be like a string or it can be a number, as you can see over here. It just expects something that will be accepted as an ID. And the good thing about GraphQL Playground, as you can see, is you can just hover over the thing and it will give you like a cool explanation of what it is. So I just wanted to get this out of the way. There's only 5 types inside of GraphQL that you can use. But you can see that I actually defined a new type over here, and I called it user. If you're used to something like, I don't know, just defining a database schema or using something like TypeScript, you're probably used to doing something like this. You create basically the structure of an object, and inside of it, you define all of the fields that this object will have and their types. And this is basically what we're doing. Imagine that in our API, we have a user that, like, we have user data. So with GraphQL, we need to define a type called user so that when we make a request that returns some sort of like the data for a user, GraphQL knows what a user is composed of. So it's very, very strictly typed in the sense that you always need to define exactly what you're going to return in this kind of ways. And the good thing is you define these types like this, but if you want to, for example, say that a user has a field called friends, right? Because, I don't know, imagine this is a social media and you want to say that each user has a couple friends, right? So what would the field friends be composed of? Well, each friend is a user. So technically friends should be of type list of users. But how can we do that? Because it is inside of the user type. How can we use the user type inside of itself? Well, in GraphQL, you can do that. You can just say that each user will have a list of users. And one of the things you need to learn is that if you want to say that something is a list, you define the type inside of it and you use the brackets around it. Now, you might find something weird here. So I told you guys that there was only 5 basic types in GraphQL: string, ID, int, float, and boolean. But you see I'm using user over here, which is exactly the point of GraphQL. You're supposed to use those basic types as part of your other types that you create, and then you can nest types that you create inside of each other. So I used user inside of user, and the good thing is when we access this friends field, we will have access to all of the other fields that each user has. So we can see if each friend is married, we can see the height for each friend, we can see the age, the name, all of this information exists inside of each type. So we can also access types and nest types that are different from each other. So for example, we'll create here a type called video. And imagine that this is YouTube all of a sudden, and we have a social media where you have a user and you have videos that you post. So the user type might have over here a field called videos posted, and by the name of it, it should be a list of videos. So we need to define our video type. So in our video, we can have an ID, which would be of type ID. We can have a title, which would be of type string. And for now, let's keep it simple. Let's just add a description, which would also be of type string. So what we can do is we can just come over here and do the exact same thing we did before and just say that this is a list of video. And now we have nested the video type inside of the user type. And this will work perfectly because we can access all of this information. Now, it might seem like we're just defining stuff right now because we are. And I feel like it's important to go over this before we start fetching data. But when we start actually fetching data from this API, you guys will understand completely why it is important to understand the structure of your data. Because we're gonna be able to access all of this in a way that before starting working with GraphQL, I had never seen in REST. GraphQL abstracts some stuff that would be very difficult to do with REST, and I feel the need to emphasize how good some parts of this technology are. So you can see we defined this over here. And one thing I also want to talk about is you might be questioning what are these exclamation marks over here. Well, GraphQL accepts either a value or null. So you can either give it two things. Either you can give it the type that we said a field is. So if we want to query a user, what we get from the API must be a string over here. And the reason why it must be a string is because we put this exclamation mark over here. But if we want to make a field be optional and we want to allow it to be null, we can just remove this over here. An example is in this user type, I only made one of them be allowed null, which is the field is married, because I don't know, I think in real life it might be weird to make it obligatory for you to put the information if you're married or not into a website. But you can see that if I wanted to create a user inside of my GraphQL API, I wouldn't need to actually put this information because it is nullable. Now over here, for both of this information over here, we have a list of friends and we have a list of videos. You can see that none of them have the exclamation mark. The good thing is that we really don't want to, because not all users will have friends. So technically for fields like this, we don't make the array be required. It just doesn't make sense. However, we might want to make the type inside of the array be required. So for example, we can say that it is not required for you to have a list of friends. It is not required for you to even have a friend. But if you have a friend, the user type must be provided. So you put an exclamation mark inside of here. If you wanted to make the array required as well, you can just put the exclamation mark after the array as well. But as I mentioned before, technically in websites, you don't need to make list of friends required. And the same thing goes with the videos posted. I don't really want to make it so that every user must post a video, but if they post a video, we want to make the field, the video type be required. We don't want to receive null videos. So you kind of are probably getting the gist of a bit of like how the language works, a bit of the basic types. By the way, types, I've used this word in this video. We call them scalars, the types that are already primitive to GraphQL. So the 5 ones that I mentioned previously, we call them scalars because they are not actually like a type composed of fields, but you can create your own scalars if you want to, and we're going to talk about that later on in the series as well. But now that we got the gist of this basic stuff over here, let's start actually working with the API that I mentioned. So in this video, we're going to be working with this API over here, which is one of the few public and free APIs I found that uses GraphQL. And what do I mean by that? Well, in order to use GraphQL to fetch data from an API, the API must support the GraphQL fetching methods. So like the way that GraphQL fetches data. So either it has to be a REST API that communicates with the GraphQL layer and between the front end and the back end, or it must be just a GraphQL API built completely using GraphQL. So you can't just go and get any REST API and use GraphQL to fetch the data. And for that reason, there's just a limited amount of free public GraphQL APIs out there. But there's this one over here called Countries GraphQL API, which is really nice because it's really simple for this video. You can see that it just returns information about countries. And when I click on the link that they provided, I come to this page over here, which I mentioned previously. It's a way for us to test the API. And it is connected to the API publicly, as you can see over here, meaning that we can officially make requests to the API. So one thing I want to go over is every GraphQL API must have something called a schema. And the schema isn't the database schema, the same thing as a database schema, because GraphQL has nothing to do with your database. It's just a schema that defines all of the data that will exist inside of the API. And one thing that is important to understand is that every GraphQL schema will have a root type called query. And this root type will contain a bunch of fields similar, and it is a type. It's called it's a type like this, and its name will be query. So every GraphQL API must have this type, and inside of here you'll have each field will be something like I don't know, get users, which is a query. So you should list all of the queries that you might want to make from the front end to request data for the API. Usually don't call it like this, like get users. This is more common with REST APIs. Instead, what you do is, if I want to make a request in the front end to get a list of users, we should probably have a field in our query type called users with an S at the end. And what it should return is a list of user, similar to what I've mentioned before. Now, if we want to just query information about a specific user, we can do something like this. We can say that this field is user without an S at the end because it makes sense. It's an individual user. And what we can do as well is we can actually put variables that are arguments to a query. So if I want to query a specific user, I can say that I want to query a user by ID. So I can say something like this. ID equals to, I don't know, of type ID. And I'm just saying that if I want to query a user, I have to pass an ID, which is of type ID. And at the end, this query will return a type of type user, like this. So I just wanted to mention this before we take a look at the schema. But basically, this is how you lay out all the different queries that you might make to your API. And you'll see this inside of this API. Because one of the good things about GraphQL Playground is that when you connect to a public API or to any other GraphQL API, it actually generates a beautiful layout of the schema for that specific API. And if I click on this button over here, I can just see the whole GraphQL schema defined in front of me. Now, this API obviously has a lot of stuff. It was actually built by really good developers, so it definitely has a lot of fields, and I don't want to confuse you guys. So if you see something that you don't understand, don't worry, you're gonna understand all of this by the end of the series. However, I want to bring into attention stuff that I already explained to you guys. So for example, if we come down here, you can see that indeed inside of this schema, there is a type called query. And this query over here, this type, defines all of the different API requests that you can make to this GraphQL API. So you can query information about continents. So apparently, based on what I taught you guys, this kind of looks like a query that returns a list of continents, right? Of a type called continent that they created on the schema. You can also just get an individual continent, and you can see that we can pass an ID, a code, which is of type ID, to get that specific continent. And it returns just a single continent, not a list of continents. There's also other fields and other queries you can make. You can make a query to countries, to a country, to languages, to a language. But basically, you can see that these are all of the queries that you can make, all of the data that you can request inside of this API. And there's some minor things that I want to point out. You can see that for some of the fields, it's not actually, as an argument, they don't actually have like a code with an ID or something like that. They actually have something called filter, which you can actually define types for your arguments, and they're called inputs. So if, for example, I wanted more than just a code to use as the variable for making this request, I can create an object containing all of the fields that I need to make this request, and I can just create them and turn them into an input. And an input is defined like this. So for example, if I come over here, close this, and I just opened this again. And I wanted to create over here a query that returns information about a user. But for some reason, I don't just need an ID for this to work. I actually need an ID and the name of the user. Well, I can do it in both ways. I can actually just come over here and also define the name of the user and say that it also takes a name as a variable and name is a string. Or I can just create an input over here and call it, I don't know, user input. You can call it whatever you want. And over here, I can define ID as of type ID and name as type string. And then instead of passing this like this, I can just pass the input as type user input. And it does the exact same thing. It's just a way to organize your queries. So with that out of the way, let's take a look at this API. So as I mentioned over here, we have the following queries. We can query for continents, we can query for a specific continent, we can query for countries, and for languages. Let me try initially querying for a specific country. You can see that to get this, to make this query, you need to pass in a code, which is the ID of the country. So like for Brazil, it would be BR. For US, would be US. For other countries, they have their specific codes. You can take a look at, like, just search on Google, like, a country code for a specific country. And from what I'm seeing, you just pass that code and it should return a country. But what exactly is a country? Let's take a look at how they define a country. So over here, they define a country as an object, right, a type, that includes their code, the name of the country, apparently native, which I'm not really sure what it is, the phone, which I guess it's the phone code, the continent to which the country is inside of, its capital, its currency, a lot of stuff, right? We can get a lot of information. So let's try running this query. How do we query information using GraphQL? Well, if we have this request over here, we have this API done over here, all we have to do is, first of all, open and close curly braces like this. And why do we do this? The way you make queries for a schema in GraphQL is you basically lay out all of the fields of an object that you want to receive. So by default, at the root of all of this, there's the query. So we're just saying what we want to get from the root query. And by opening and closing curly braces like this, we're already saying that we're trying to grab one of these fields over here. So we specify which field we want. So I want the country. So I just come over here and write country. Now country requires an argument. So I can just pass in the argument, which is code. And I can pass the code for this country. Let's try querying the US. So I'm going to put US over here. Now country as a field returns a type that is not one of the GraphQL native types. It's not like a string or anything like that. It's a type that was created inside of GraphQL. So it is a type that was created inside of this schema. So in order to actually get this information, whenever we have a type, like a field that returns a type that isn't one of the basic types from GraphQL, we actually need to specify what we want from that type. So to specify, we open and close curly braces again. So for each field that you want to get information from, you just open and close curly braces and specify which fields you want. So country should return a country type. So let's go to the country type. The country type has all of these fields. So we specify which fields we want. Let me get the ID, which is actually called code. Let me get the name of the country. And you can just list out whatever you want. Let me try to get the phone. Let me try to get the capital. Let me try to get the currency, whatever you want. And if you want to run this query, all you have to do is you just have to click on this button over here and it should run the query. And every GraphQL query gives a similar response in the sense that the format of the response will include an object, which the first field will be a data field, and inside of the data field will include the data that you queried. So the data field will always return in the format starting from the root query, this type over here, the one that I said that every GraphQL schema must have. So initially, we say that we want to get the country from the root query, so this one over here, and the country type, the data that was returned was the code the name, the phone, the capital, and the currency, because those are the ones we specified, and we can get this information. Now, I did leave out some of the types that country included, because I wanted to point out something. You can see that, for example, continent as a field isn't a basic type from GraphQL. It's actually a type called continent that was created by this API. So let's take a look at the type continent. Well, the type continent includes a code, a name, and a countries field. So if I wanted to come over here and say that from my API request, I also want to get the continent from this query, I couldn't just do it like this. You see, it will give us an error because we need to specify what from this continent I want to get. So I want to get the code, I want to get the name, and I want to get the countries inside of this continent. Oh wait, but again, name and code are fine because name and code are types that are basic to GraphQL, but countries is actually a list of the country type. So we need to specify again what we want for each country in this list. So let's just get the name of the country, and what we're going to get if we run this over here is we're actually going to get the United States, then we're going to get like all the information that we had previously, but now we're getting the continent field, and inside of this continent field we get the code NA for North America, which is the continent where the US is located at, and then the name North America, and then we get a list of countries, and each country only returns the name. So this is one of the good things that I mentioned in the previous video, where you can specify in the front end, in the place where you're making the API request, what you're trying to get, so that you only download the data that you need. So if I wanted to get more, I wanted to get like let me try to get also the capital for each country inside of the countries list. So let me just come over here and say capital. You can just specify capital, and now all of the countries also include its capital. So it's nice, right? You have all of these objects and types that are nested inside of each other, and when you query information, you can just get this data like this. Now, the structure is a bit hard to get used to. I understand that it's much easier to just get used to making like a fetch request, like an API request, a GET request, to an endpoint and specifying what you want in the backend, what you want to send in the backend. However, with this, it becomes so much easier once you start getting the gist of it, because you're just telling GraphQL what fields you want, and it will literally give it to you without any actual work from the backend. So now the final thing I want to do is just a little exercise to see if you guys understood completely everything that we explained in this video. By the way, I'll be responding every question you guys leave in the comments, at least until a point, because I really like teaching about GraphQL, really like talking about GraphQL. So if you have any doubts, I'm super free to answer, because I'm actually really excited to help you guys with this series overall. So the last exercise that I want to talk about is instead of querying a country, let's try to go over here, go to the root query type again, and let's query the languages field over here. So if you want to pause for a second, you can see that this is one of the fields. It does return a list of languages, and there's the language type exists over here, so just check it out. Take a look at what fields you want. And also keep in mind that there's an input over here called filter. So you need to take a look at what language filter input is. And apparently it's this over here. But my recommendation is that just ignore this. You can see that there isn't actually an exclamation mark over here, which means that you don't need to pass this variable as an argument. You can just query for languages and it will return the information. You don't need to pass an argument. Differently from like if you pass for stuff like continent or country where the ID is required, you don't need to actually pass anything. And I would just ignore this for a second. Just try returning a list of all the languages inside of this API. And pause the video, do that. If you get stuck, don't worry. I'll be here to help you out. Just comment anything and I'll be able to answer. But I'll show you guys how to do this in a second. So if you paused or you didn't, it doesn't really matter. I'm going to explain to you how to actually do this and make a request to query the languages list. So as I mentioned before, inside of this over here, whenever you want to make a request to a GraphQL schema, you need to assume that it's already in the root type called query. and this query type, and that means that you can just specify directly by opening and closing curly braces which fields inside of the query type you want to get, right? So over here we just want the languages field like this, and again, we don't need to do something like this because this is optional, and I really don't care that much. I don't want to specify any filter that I want to pass to this languages. I just want to receive the list of all the languages. So I can just open and close curly braces again, because this returns a list of a type which isn't a scalar type called language. So we go over here and we specify what we want to receive from each language. So from each language, I just want to get their names. So let me get name, then let me get the code as well over here. Then let me get native, which I really don't know what it means, but let's see what it is. And RTL, which I also don't know what that means, but let's see what it is. And if this is right, it should return a list of all the languages inside of this API. And for each language, there should be a code, a name, a native, and an RTL. Let's click run. And you can see that apparently this is what happens. We receive in our response an object with a field called data, and then a field called languages because it's what we're querying. And then inside of it, there's a list of languages. And each language includes a code, a name, and a native, which I guess it's like maybe the native way of writing the language name. Yeah, probably. And RTL, I have no idea what it is, but you can see that this is working. And if you were able to do this, that's awesome, because it means you're starting to get at least the basics of the GraphQL query language. And that was my hope for this video. Feel free to ask anything in the comment down below. As I mentioned, I'll be able to answer everything. I'm here to help you guys. I'm really excited for the series, and I really hope this was a valuable video. In the next episodes, I'm going to show you guys how to build an actual GraphQL API. So we're actually going to be writing code, and I'm really excited for that. I thought it would be nice to actually present this before we get to that point, because I just feel like that would be not a lot of people do that, and I feel like if you go directly to the code, you will start getting really confused with stuff like this, and I feel like if I did it this way, it would have been more beneficial. Today we're actually gonna finally start writing code in GraphQL. And in order to start writing code in GraphQL, we're gonna start in the backend, obviously, because we're gonna build start building our first GraphQL API. And to do that, we're gonna be using JavaScript, NodeJS, and the Apollo server library. Those are very commonly used technologies together. Apollo server is probably one of the most famous GraphQL libraries out there to create your GraphQL API using Node.js, and it has a really good community. So that's why I chose to teach you guys that library. So what we're going to be doing is we're going to build a simple application. I'm not sure if we're going to finish everything on the backend today. Remember that as the series continue, I'm going to constantly be adding more and more stuff to the tutorials. So the project might seem small now, but we'll be adding more stuff which will require a bigger complexity, and we'll teach you guys more advanced stuff later on in the series as well. So as you can see over here, we have like an empty project opened up inside of VS Code. And what I want to do is I want to open up my terminal over here, and I want to start by initializing a new Node.js project. And for those who don't know, in order to initialize a Node.js project, all you have to do is you have to run npm, which is the package manager I'm going to be using for this series, and then you run init. And it should start asking you a bunch of questions, like as you can see over here. You just press enter to all of them, and it should generate a package.json automatically for you, which saves us some time. Like writing this. But yeah, that's basically what we wanted. And now that we have our package.json, what we need to do is we need to install a few things. The first thing we want to install is the Apollo server library. So I'm going to say npm install Apollo server like this. And this library, as I mentioned, will allow us to connect, to make our API into an API that serves GraphQL. But we also need to install the GraphQL package, because we need it in order to write actual GraphQL language. Like, to use the GraphQL language and write our definitions, we need to install the GraphQL core package. So I'm going to press enter, and it's going to install both of the packages. And now that both of them have installed, you can see that they are over here in my package.json, and these are the versions for them. So if you want to check them out, these are the versions I'm using. Then what I want to do is I want to quickly just install NodeMon as well, because I don't want to keep restarting my server every time I make any changes. So I'm just going to say npm install NodeMon like this. And while NodeMon is installing, let's set up over here really quickly a script that when we run npm start, it should actually start our application by running the command nodemon and index.js. So we're going to create a file called index.js, and when we run the command npm start, it should run this over here, which means it's going to run nodemon into our packages. So now that it finished installing, let's start by creating our index.js file. So I'm just going to create over here index.js, and this is going to be the entry point of our API. And to get started, if you're used to using Node.js with something like Express, you will notice immediately that the way we're going to set up our API, it's going to be a bit different. We're not actually using Express. As you saw, we didn't install the Express library. But in order to set up the API with GraphQL, all we do is we first import some stuff from the Apollo server library. So we're going to say const equals to require, and we're going to require it from the Apollo server library. And the one thing that I really want to import from it right now is just the Apollo server instance, like this. So this over here is a class, as you can see, and it contains all of the configurations and stuff related to configuring our API to work with Apollo, to work with GraphQL. So what I want to do is, over here at the bottom, I want to create an instance of this and call it server, and set it equal to new Apollo server, like this. And one thing that I want to tell you guys is, you might encounter code written in GraphQL that looks a little bit different from what we're writing right here. And it is because GraphQL has a bunch of libraries that do the exact same thing for Node.js and also for React as well. There are many alternatives. The most famous one is Apollo server, so that's why I chose it for this. But there's other ones that I actually have tutorials on my channel. For example, there's one called Express GraphQL, which is also very famous, and if you want to check it out and use that one, you can just check my video. However, I'm just saying this because don't worry, all of them do the exact same thing, and it might seem kind of weird in the beginning. You might think that you need to learn all the different libraries, but you really don't. After you learn one, it becomes a lot easier to transition into another one. And now that we got that out of the way, let me talk a little bit about this Apollo server class that we just created, right? We just instantiated a new instance of this Apollo server class, and we set it equal to server. Well, for the Apollo server class, it will actually take in two pieces of information. The first one is some type definitions. So let's, for now, just write here type definitions or type devs. And the second one is a bunch of resolvers. Now, I understand that if it is your first time working with GraphQL and you're following the series, those two words might be kind of weird. I did mention resolvers, I believe, in the first video, but basically everything, every piece of data, every type that you define, every query you define in GraphQL, everything you do will exist inside of this type devs variable over here. And also, all of the functions that resolve those types and do stuff like make calls to APIs, make calls to databases, send data back, all of those functions that does that kind of stuff will be enclosed inside of a variable, and we're going to call it resolvers. So what we do is, right now, those two values don't exist because I haven't created them yet, but we are going to pass them over here. And I just wanted to mention that these resolvers are just functions that deal with the data. So like make a database call to insert data into a database, that kind of stuff. And type definitions are similar to the stuff we did in the previous video where you define your types. So I wanted to differentiate both of them. And now that you kind of, for now, set up the server variable, what you got to do is you got to come down here and just say that you want a server listen. So you want to tell the server to listen, and when the server finishes listening, this returns a promise. So after the server is actually running, we just want to basically grab over here a function, and this function should, let's just create it right now. It should just console log some information. Like, for example, it should console log your API is running, like this, and a happy face. And you can also actually grab the URL from here. So the URL in which your API is running at. So if you want to do that, you just destructure the object over here and grab the URL. And you can use that over here if you want to. We might do it like this by using backticks and then just inserting the URL and doing something like at, and then putting the URL over here. I'm just going to put the money sign and the curly braces and just put directly the URL inside. By the way, this is white, but it's because of my theme, but this is a string. Don't worry about this. It's just a string with a URL inside. Now, what happens if we try running this right here? Let's open up our terminal and let's try running npm start. You should see initially that it will crash. And the reason why it's crashing, it's because of what I mentioned earlier. We haven't defined any types for our GraphQL schema, and we also haven't created any resolvers to resolve those data, that data, right? So we need to do that right now. And one thing that I want to do is I want to show you guys a little bit of folder structure and how to organize your GraphQL project. So usually when you are working with a GraphQL project, you want to hold the information related to your resolvers and your types and everything inside of a folder called schema. Now, I've seen this same pattern being used in many places, and that's why I use it. But I gotta remember, you guys, that there isn't a correct pattern for structuring your folders. However, this is what we're gonna be doing in this tutorial. We're gonna create this folder called schema, and inside of here, we're going to divide it into two files. The first one is our type definitions. So I'm going to call it just type devs like this, and then .js. And the other file is going to be called resolvers like this, and .js as well. And now, as you can imagine, in these files, we're going to write the type definitions and the resolvers that are going to be passed into our Apollo server, which will make our actual GraphQL API run. And in order to actually resolve any data, we need to create our own types. So we're going to finally start writing our own GraphQL schema that is going to define our API. So over here, we're actually going to import some stuff from the Apollo server library. So from Apollo server, what we want to import is something called GQL, which is just a variable that is going to allow us to write like pure GraphQL code, and it's going to automatically translate that code into something that JavaScript understands. And in order to do that, we're going to come over here and we're going to create a variable called type definitions like this, and we're going to set it equal to GraphQL, and we're going to open and close backticks like this. And inside of here, we can write pure GraphQL code. But one thing that I want to tell you guys is that you should see that it's kind of weird because we're writing code inside of string templates, so like inside of backticks, which for many of you guys initially it shouldn't give any syntax highlighting or any code completion, but for me it will, because I actually have like a library installed. Actually, it's not a library, it's an extension, and the extension is called let me just see over here, extensions, and it is this one over here, Apollo GraphQL. You can install this right now, and it should allow you to have like this syntax highlighting inside of the strings, or else you will just be writing code inside of actual quotes, which is pretty annoying. It looks a lot better when you do it like this. So I would recommend installing this extension over here. And when you do so, you can finally start writing your GraphQL code. So in the previous video and in the first video as well, I mentioned that every GraphQL schema starts with one specific type, and that type is called query. So we technically need to do this. We need to create this type called query, and this type over here will hold as fields all of the queries we want to make inside of our API. So for example, if we have a website and one of the requests we want to make to our API is grabbing a list of users, we might want to define a query called users over here and say that it returns a list of users. If we want to get, I don't know, imagine it's suddenly Facebook and you want to receive a friends list, then you might want to define a field over here called friends, and this is the only way you can actually define queries that are going to be in the front end. So keep in mind that the query type is the first level of our graph. Now I don't want to really get too deep into the graph aspect of GraphQL, which is kind of dumb because GraphQL is made out of graphs, but I'm gonna talk about that later on in the series. You gotta think about the whole API as a graph, and the first level is the query type. Now let's think about what we're gonna be doing. I actually want to create a very simple application, which is going to be kind of like a normal application where you have data about users. So in order for us to have data about users, we have to create a type called user. So I'm going to come over here and I'm going to create a type called user. And to create a type, you just write the syntax like this, like we did in the previous video. And if you recall, the way you actually define stuff, like the way you define the fields for a user, it's pretty simple. So you come over here and you write the name of the field. So a user might have a name. And then you write which type that field returns. So a name would be a string. And as I showed in the previous video, string with a capital S is a type in GraphQL. And we do want to make this field required. And as I showed before, to make a field required, you just put the exclamation mark at the end. So whenever we either create a user or just request a user, name can never be empty because you can never have a user without a name. So we make it a required field. So what we want to do now is we also want to give it I don't know, a username, and it's also going to be a string. Then maybe the user might have an age. We might want to do that. And for age, we're actually going to be using int, which is another type. And then what we want to do is we might want to have a nationality. For example, we can put over here nationality. And for now, let's say that the nationality for the user is of type string. And the reason why I'm saying for now is because this will change later on in the series when we get into more advanced topics. I'm actually going to make it so that you can only actually pass nationalities, so like actual countries, instead of any random string. But that's for later on in the series. Right now, our type user can only take in this kind of information. And now that we have defined the type user, we can start creating queries that deal with this type. So as I mentioned in the past, we might want to get just a query which return a list of all the users. So let's just call it users like this. And let's just say that it should return a list of the type user that we just created. But right now it just says that it's returning a single user. So in order to say that we want to return a list of the type user, we just wrap this around with this brackets to say it's an array. And let's make it required as well by putting an exclamation mark like this to say that if we want to grab the users, we want to actually return a list. We don't want this to be able to be null. And if we receive a list, every user inside of it can't be null, so it should be required as well. We're just saying that inside of the query type, there is a query called users, and it should return a list of users whenever you query it. So this is fine. It looks really nice. And for now, let's just keep our API pretty simple. You're only going to be able to make one query and request data about users. That's basically it. And that's fine. What we want to do is we want to actually have some data to deal with. Right now, you can see I don't have any data. And what my plan for this series is, at least for now, I'm not going to be using any actual database because I don't want to make this series be kind of weird for people who use different kind of databases. If I use one database, then a person who doesn't use that database or doesn't understand that database won't be able to follow. So my thinking is maybe I'll just use some fake data, dummy data like JSON, and I'll tell you guys exactly where you should be making your requests to your databases, and I feel like it won't impact the series that much. So what I want to do is I'm going to create a file over here, and let's call it fake data, like this, fake data.js. And inside of here, I'm gonna have a list called user list, like this, user list. And what I want to do is I'm gonna come over here and I'm gonna add the fake data, and I'm gonna come back in a second just to show you guys all the fake data done. Okay, everyone, so as you can see, I did generate some fake data. The list over here includes each 5 objects, and each object contains information about a user. And as you can see, the data that I put over here matches the data, the type of user we created over here. It does have a name, it does have a username, it does have an age, and it does have a nationality. One thing that I forgot to add for the user type, which is kind of like a really bad thing because you should always add that in GraphQL, is the ID type. And it's a field inside of a type, and GraphQL by default has a basic type called ID, which is similar to a string, an int, and other basic types. An ID can take in either an integer or a string, and it just serves as an identifier to a type. So now let's save this, and this is our database over here. So now that we have our data, we have our type definitions. Can we actually make this work and actually make queries to our API? Well, no, because GraphQL, just having this information over here doesn't work that way because they don't actually know what to do when you make the query. So as an example, I'm going to come over here and I'm going to first of all export this type definitions object that I created, and I'm going to say module.exports like this and set it equal to type devs, so type devs. And if I come to our index.js, now at the type over here, I'm just gonna import this file that I just created. So require from the path towards the file, so it would be ./schema/typedevs like this. And what we want to import is the typedevs variable that we created, and now it's passed on, so it should be working. Now, do you think it's gonna work if I run this application? Let's test it out. If I open this up over here, it was already running, and you can see it crashed because it still doesn't have the resolver functions. And resolvers are just functions that resolve queries that you have. So what exactly do I mean by that? Well, over here, you can see we have a users field, right? So we do need to create a resolver that is going to resolve this field over here. So we need to say that in the side of this users field, it should return a list of user. So how exactly do we do that? Well, we can come into our resolvers function or resolvers file over here, and we can start by creating an object called resolvers, which we're going to pass inside of our index.js. And this object will contain all of the resolver functions that will exist inside of our API. So all of the functions that make calls to databases, all the functions that decide what we return to the front end, all the functions that actually do something in our API will exist inside of this single resolvers object. And the way we define it is we first define what is the highest level field for inside of this object. So in our case, it is the type query. And we just come over here and we write query. So inside of the query type, we define all of the resolver functions that will exist as a subfield for the query type. And right now we just have one field, which is users. So we need to define a resolver function for this users type. And to do that, we just come over here and we can call this resolver functions exactly what I called it over here. So if I call this users, I like to call this function users as well. And it's a function, so we define it like this. We open and close parentheses, and we open and close curly braces. And inside of here, we can write all of the JavaScript necessary to tell GraphQL what we want to return whenever someone makes a query to the users field. And that means that if you have a database, it is over here that you make an API call to your database to get data about users, and then you return at the end the data, right? We don't have a database, we have a file called fakedata.js. So what we want to do is we're going to import the user list that we created like this, set it equal to require, and we want to require from actually I need to go back twice and then go to fake data. And one thing I just realized is that inside of this fake data.js file, I did export const. I can't do that because I'm using modules. So I actually need to come here at the bottom and I have to say module.exports equals to the user list that we just created. And I'm going to close this, and inside of our resolvers, we can just import the user list that we have right now. And inside of the users query, what do we want? Well, we did have a type called user, and our field is called users. So it means that we want to get a list of users. So we already have a list of users in our fake data.js. So all we want to do is we just want to return that data. So what we do is we just come over here and say user list is exactly the thing that we want to return. So this over here should be working, and let's just export it by saying module.exports and set it equal to resolvers like this. And now we can access this inside of our index.js the same way we did with the type definitions, and say something like resolvers like this. And now we'll just grab this over here, and it should already be passed. Since it's passed, it should be working. If I actually open my terminal, you can see that now instead of crashing, it's actually saying your API is running at localhost 4000, which is honestly amazing. And if I just grab the URL over here, localhost 4000, and I actually try to go into one of my browsers, you'll see that this message appears, which is a bit different if you're familiar with something like REST. And what this says is that the Apollo server library actually has a built-in API tester that we can use. And to use it, you just click on this button, query your server, and it should bring us to the Apollo GraphQL Studio, which is this beautiful thing over here. Now, the good thing is it recognizes that our API is running, and it actually gives you a list of all of the fields inside of the query type. So we have a users field, and it does know that automatically because it actually creates a beautiful documentation for you inside of the studio. You can actually check out more stuff. You can look at the schema and see stuff like, oh, what is the type user? Well, we created this type, and it actually has like a whole documentation for it, as you can see over here. All of these fields we added inside of our code. But if we actually want to write a query as if we were making a request, all we have to do is we have to come to this operations tab over here, this widget, and we have to structure our query as follows. First thing we write when we want to write a query is the word query. Now, this is a bit different from what we did in the previous video, and it is because depending on where you're making your request, you might not need to actually write the word query. However, we do need that right now because we will need that when we use Apollo client inside of React. It uses the same format, so I highly recommend just doing it like this. So you write query as your first thing, then you write the name of the query you want to write. So let's call it get all users. You can give it whatever you want. And inside of here, you specify which fields you want to get. Remember that by default, the first level is the query type. So what is the only field that we have inside of the query type? We have the users field, which is exactly what we want. So we can write over here users, and since users return like a list of the object user, we do need to specify which actual fields inside of user we want to receive in our request. So one of the beautiful things with GraphQL that I mentioned in the previous video is that you can actually select which fields you want, and you can just not receive all of them if you want so. So what we want for now is we actually want all of the fields. So we want to grab the ID for each user, we want to grab the name, we want to grab the age, we want to grab the nationality, and I'm pretty sure that's it. And if our API is working, when we click on this, it should run a query called get all users, and as you can see, it didn't work. And the reason why it didn't work is it says there was an error, and it says cannot return null for non-nullable fields in query.users. Oh, that's interesting, right? The reason why it's interesting, by the way, this wasn't intentional. I thought it was gonna go. The reason why this is interesting is because differently from REST, GraphQL has a built-in error handling system. So it actually gives you back the error exactly how it is. You don't need to define anything. And you can see right now it just says that the message is that you cannot return null for non-nullable fields in our API. So it's very simple to solve that. We just go to our field. We'll take a look at what we created. I actually figured out what the error was, and it was pretty dumb. I just accidentally, for the resolvers, instead of importing from the resolvers file, I was importing from the type definitions file. So basically it was like this, which obviously it's wrong. So it wasn't recognizing the resolvers. So now that I can save this, let's come over here to our application and let me run this query again. When I click get all users, you can see that now it actually lists out the list of all the users we have in our application. And since we specified all of the fields we wanted, each user contains each field. But if we wanted to just get the nationality for each user, we can also just get the nationality for each user. So in the front end, the one who makes the request can specify what they want. And I just find that really cool. And you can see that it works perfectly with our data. And it only works because we have here our type definition, we have our type called user. Inside of our query type, we have a field called users, and we have this field, and we have a function, a resolver function named users as well. And you can see that this resolver function is returning the correct data. Now imagine that, for example, we saw over here that we said that, for example, nationality was a string and that it was required. So by being required, we mean that it can't be null. Now, what would happen if I made it null, right? So I'm going to grab my list of data over here, and I'm going to make one of the nationalities null, and let's see what would happen. If I came over here and I asked for the nationality and I try to get all users, you'll see it won't work because it recognizes that it received a null value for one of the nationalities, and while it has to be required because that's how we defined it. So keep in mind when you're working with GraphQL and when you're defining your schemas, yeah, that's pretty much it. If you started the series from the last episode, you know that we went over how to build or start building a GraphQL API using NodeJS and the Apollo server library. And today we're going to go more in depth on that subject and actually increase the complexity of our API so that we learn more stuff about GraphQL as a whole and the different aspects of the language. So before we get in the tutorial, if you guys could leave a like and subscribe, I would massively appreciate it because it would help push my videos to more people. I'm very thankful that recently we hit 20k subs, and it was all because of you guys, and the more you guys like my videos, the more it gets pushed. So I would really appreciate if you guys could do that. And yeah, that's basically it. Now let's get into the tutorial. So in the previous video, as you can see over here, we built the building blocks of our API. So we have our type definitions over here in this file, and we also have our resolvers in this file. We're using fake data, which is this one over here. It's just an array containing like a bunch of objects containing users, and the format of our data, the structure of our data is defined in our type definitions. Since we only have one field, which is a query, we only have one resolver with the same name, which resolves that data, which in our case, it just returns the data so that whenever we want to query some data and we specify that we want to query users, it will return the data correctly. And we can easily just come over here and add more fields from the user type, and it will also include those fields when we make the request. But that is stuff that we focused more in the last episode. How do we actually increase the complexity of this schema and learn more about GraphQL? Well, the first thing I want to teach you guys is there's something in GraphQL called enums, which is very similar to how enums work in different languages, but it's very useful in GraphQL because it allows you to validate data very easily. So an example of an enum we might want to have in this project is the nationality field over here for a user. And the reason for that is because there is a limited amount of nationalities, and you only want to allow a user to make a request and include a nationality if it is actually like the name of a country. We don't want someone to make a request and add a nationality that isn't an actual country in real life. So one way we can validate that and prevent them from doing that is we can actually come over here and we can create an enum. So to create an enum, we just come over here and write enum like this and give the enum a name. I'm gonna call it nationality like this, nationality, and I'm gonna open and close curly braces. And inside of here, we just list out all of the different possibilities for which nationality can contain. So for example, in our fake data right now, we have a person from Canada, a person from Brazil, a person from India, someone from Germany, and someone from Chile. So just to be sure, like just to make this simple, I'm obviously not gonna add all the countries here, but in the real project you probably should. I'm just gonna add the ones that we already have here in our fake data. So I'm gonna add Germany, and then there's Chile as well. Now you might notice that I'm actually writing them in capital letters. There's no real reason behind it. I believe it is standard and best practices to have your enum types as capital letters. But the problem is that when you have them in capital letters, they need to match what you pass in the data. So I can't pass Canada like this because it's not like it's case sensitive. So that we define the type with capital letters. So the data should also include capital letters. So I'm just going to change that right now. I'm going to make everything over here into capital letters as well, and we'll just that will work perfectly for us. Now I just finished putting all of them, as you can see over here, all of them have capital letters, and you might wonder, okay, we created this enum, but what do we do with it? Well, now instead of saying the nationality is a string, we can say the nationality is of type nationality, because now this field can only accept fields or values that equal the ones listed out over here. So if we go to our API over here and we try to get the list of users, you'll see that it will work. Now the values are all in capital letters because we changed them. But the difference is, if I came over here and I added something that isn't a country, I'm just going to put like a bunch of letters, you'll see that it won't work because the value that we put in our data doesn't match one of the options in the nationality enum, which is very useful in GraphQL because the whole point of GraphQL is specifying the data and structuring your data and your schema in a way such that you're preventing failures like this one. So now that we went over enums, we're going to use that throughout our application. Let's start adding more complexity to our user type. And one thing I want to do is I want to allow a user to have a list of friends that they have in their application, right? So we can come over here and we can just say that the type user has a field called friends. Now, what will be the type friends? Well, each friend will be also a user. So we can say that friends will be of type user. But again, friends has an S at the end, so it is multiple friends, meaning that friends should be a list of users instead of just a single user. And we can do this, as I mentioned in the second episode, or the first one, I think it was the second one. We can nest like a types inside of each other's. So inside of the user type, I can have a field which is of type user or list of users. And we don't want to make this required because unfortunately some people might not have friends. So we don't want to we want to allow them not to have friends. That's something that you should probably allow people to have, or else that would be pretty mean. So we just created this field, but what do we do now? If we go to our API over here and we add friends to the field, to one of the fields we want to query, you see immediately it requires us to open and close curly braces because friends is of type user. So we need to specify what fields from the user type we want to get for each friend. So for now, let's just grab the name for each friend and the age as well. Maybe just those two. But you'll see that if I run this query, friends will be null. And the reason for that is because our data doesn't currently have the field friends, but it does run the query because we said that friends isn't required. So it's totally fine for there not to be friends, But if we try to access someone, like the friends for someone who doesn't have friends, it will return no. So how do we fix this? How do we actually add some friends to some people? Well, for John over here, I'm going to add a field called friends, right? And I'm going to make this a list, and inside of it, I'm going to add some other users that we have here in our project. The first one, I'm going to add Pedro, because Pedro will definitely be friends with John. I'm also going to add Kelly over here, like I just copy and pasting. And for now, I think that's fine. Let's just give John 2 friends. I'm also going to make Pedro be friends with someone else. Let me see. I'm going to make Pedro be friends with Sarah. So I'm going to add friends, and I'm going to add a list and just add Pedro inside of here. So Sarah will only have one friend. Now if we come over here and we query, you'll see that now Pedro includes a list of users, and each user only includes the name and the age. And Sarah does the same thing, but only includes Pedro. And I hope that you guys are like starting to feel as excited as I was when I started to realize how easy it is to do stuff like this, to nest objects and be able to relate stuff to each other. GraphQL has a very specific way of handling and returning data. So if you master this structure over here of how does of which level you start at, which fields you're querying, what types you're using, you'll definitely be able to work with any GraphQL API, and your life will become a lot easier compared to how your life was when you were working with REST in a front-end application. So we just added this type over here, and it definitely looks good. Now what I want to do is I actually want to add a new query to our query type. We just have currently the query called users, and it is cool and all, but it's very simple. We just have one resolver, and all it does is returns a list of users. But the query I want to add right now is to get information about a single specific user. And the reason why I want to do this is because it's very common in applications. Like if you have a profile page, you can get information about the user by using this query and display that information in the page. But also because it will teach you guys a very important topic in GraphQL, which is the topic of using arguments, which I mentioned in the second episode. You can actually create a query like this, and inside of it, you can add certain arguments that you need to pass inside of this query to make it work. And the argument that we want to use for grabbing a user would be passing the ID, right? Because usually when you want to query a user, a specific user, you pass the ID, which is the identifier, and it will be able to use that information to get the user for you. So what we can do is we can specify that this field over here, or this query, has to get a field called ID, and we need to specify the type of it. In our case, the type would be ID, which is something from GraphQL. And we're going to make it required because you shouldn't be able to query a user without passing an ID. But then we also need to specify what is the return type for this. And as you might imagine, it is just a single user like this. And we're also going to make it required because if you want to query a user, you should receive back a user. Now, the thing is, you don't need to make this required. Technically, it depends on how you want to handle your data. Because if someone passes an ID that isn't an ID of a user that is in your database or in your API, then this will break if it is required, because it will try to find a user that doesn't exist and it won't return a user. Now, the thing is, if you want to handle your data based on that error message, then you can leave it like this. But if you're fine dealing with null results, you might know that, like, oh, if I returned null, it means that there was no user, and then you deal in the front end with that and you figure out what you want to do with that. But for now, let's just make it required like this, and it should be fine. Now we just added this field. What do we do now? Well, if we added a field into the type query, all we have to do is we have to add a new resolver, and the resolver will be inside of the query object because it is a query, and inside of it, it has to be exactly the same name as the one that we defined over here, which is user. So we just say user like this. Oh, and by the way, there's a couple ways of defining these functions. I defined the resolver function like this, but one way you could do it is you can actually just use the arrow functions like this. And I actually prefer it this way. I don't know why I used the other way in the previous video. So I'm going to continue using it like this for the rest of the tutorial. So we're going to define a user resolver, and we're going to create a function out of it like this. And there's a single difference between this field and this field over here. And the difference is that this field doesn't require an argument, but this one does. So now I'm going to introduce to you guys one important topic in GraphQL, which is dealing with the different arguments and stuff that you can grab from a resolver function. And I won't go in depth on all of them. I actually will only mention one of them, which is the one we're going to be using right now. But throughout the series, I will definitely go over every single one of them so that you guys can understand everything. The first one that we can grab is called parent. And to keep it simple and short, all it does is it gives you the value that was resolved by a parent and the chain of types. Now I know that's confusing especially because we don't have an example right now in our schema that is useful for which makes parent useful, but we will definitely work with that later on. And since it's not useful, we'll just pass underscore like this, because the thing is we want to access the next value in this argument chain, which is called args, to have access to the ID that we pass in this field. So if you don't want to use the parent, you just put it like this and you access args. And args, as I mentioned, is an object that contains whatever data the user passes in the argument of the query. So in our case, it will only include ID. So what we can do is we can access that ID by saying something like args dot ID. I don't know why it was capitalized, but something like this should have access to the ID which you used for your query. Which means that in our case over here, we want to return a single user with the ID that was passed over here. So we're going to create a variable called ID and set it equal to args.id, something like this. And then what we want to do is we want to find the user with that specific ID. And one thing I want to use is, if you recall, we're using fake data, we're using this array over here. If you're using a database, then here is a good time to use this ID to select a specific user from the database table using the specific ID. Since I'm not using a database, I'm going to be using something called Lodash, which is a library that it's already installed. You don't need to install anything, which allows you to very easily do this kind of operations with arrays instead of databases. And I'm going to use it because it facilitates, and it kind of looks like how you would use a database to get data. So with Lodash, what I can do is I can, for example, say const user equals to underscore, which is what we called this over here. Oh damn, I just realized that I called this underscore and this is underscore over here as well. So for now, I'm just going to call this parent, which is fine. You can call it whatever you want. I'm just not going to use it. And then what we're going to use is this underscore. We can just say dot find like this. And with Lodash, you can specify a list over here in the first argument, which in our case will be the user list. And then you can specify basically what you want to find inside of this list. So our list is an object. So we want to find the user which has the field ID equal to the ID that we have over here. And since JavaScript allows you to if you have an object and a key is equal to the value, it has the same name, so ID is equal to ID. We can actually we don't even need to do that like this. We can just write ID, and it's just shorthand notation for whenever you have a key and a value which are the same name. And this should return a single object inside of this list, which contains the ID equal to the ID that we pass in the argument of this resolver. And finally, what we want is we want to return this user. Now, this resolver function looks fine to me. Let's look at our terminal. It seems like it didn't break anything. Now let's test it out. Let's see if it's working. Let's come over here. I'm gonna comment this out by just putting a bunch of hashtags over here. It should comment out in GraphQL. I'm gonna zoom in so you guys can see it better. But what we want to do is we want to add another query, and this would be, let's call it get user. And with this query, what we do is we open it like this, and when we query the field inside of the type query, we now want to query the field called user instead of users. So we say user, and it knows that it requires an ID. So you can see that automatically using our Apollo GraphQL Studio, it already built it like a whole system that includes the ID. It called the variable user ID, it gave its type, and it just added it like this. The thing is, when you're querying information in the front end and you want to make a query to GraphQL and it has some sort of argument, this is the format that we're going to write. I'm not going to go too much in depth about this right now because we are not working with the front end yet, but we're going to pass the value of our argument, which is going to be ID, down here at the bottom, which the Apollo GraphQL Studio allows us to just pass it like this. So we can now specify what from our user we want to receive back. So let's just say we want to receive back the name, the age, and the nationality, right? And now let's query a user. So to query a user, you just have to specify the ID, and currently I don't know the ID for the users. Let's come to our fake data. Let's get Rave. So Rave is ID 4. So we just pass 4 over here instead of no. And when we run this query, you see that it doesn't work because it says cannot return no for non-nullable field in query. Now you can see that this gave us an error, and it wasn't intentional again. I know what the error was. You can see that we defined our type of our argument ID to be equal to ID. And the type ID in GraphQL can either be a string or a number. If you click on this over here, it doesn't even give us an explanation, but yeah, but ID should be either a string or a number. But the thing is, we're specifying here that the value we're passing is 4, but when we get it inside of our resolver over here, we get it as a string and not as a number. So when we use Lodash to find the user by ID, it's passing a string for the ID, and that's why it's not finding anyone over here, because our IDs are all numbers. So technically, to resolve this, all we do is we actually say that our ID is equal to the number value of our ID from our args, and we're just converting our string into a number, and this should work fine. I'm gonna save this. We're gonna come over here and let's try querying for Rave again. So if we click on this, you can see we get Rave perfectly fine. If we try getting, for example, Pedro, we can put 1 over here, and oh, it's not Pedro, it's John, yeah, and it works perfectly. And if we want to add the friends property over here for John, and we only want to get the name for each friend, we can click on get user, and now it specifies everything we want from the user. You can see it's pretty simple. After you start working with different queries and different types, it becomes a lot simpler to run or to work with your GraphQL schema, and it's starting to actually look good. We're starting to give it some complexity, which is pretty nice. Now, what I want to do is I want to introduce a new type to our schema, which will interact with our user type. And I'm going to very quickly, because now you guys are starting to get used to how to create queries and stuff, I'm going to very quickly add some queries for that type as well. Now, the type I want to add is called movie. And the reason why I chose this is because I wanna create a new type in our API that isn't really related to user, but you can like connect both of them in some way. So for example, the way we're going to connect it is I'm going to come over here. I'm going to create the type movie like this. And let's think about what a movie contains, like what kind of information. Well, the first one it will contain is an ID, definitely, because everything must have an ID. Then a name for the movie like this, and it should be a string as well. Then what else? Maybe year, in which it was like year of publication. We can call it like this. Oh, I hate this. It's a huge field, but it should be int, right? And what else should we get? We should probably get something like a boolean. Let's think of a boolean that is good. I thought about maybe just putting like is in theaters. Like this, just because it's a boolean, because maybe a movie isn't in theaters. Like there are some movies which doesn't get a release in theaters. So I just wanted to add a boolean because we haven't worked with a boolean type yet. So I just wanted to add it like this. And now I just want to keep it simple. These are all the types for our movie. So how do we actually query our movies, right? So the first thing we want to do is we want to add a field over here called movies. which is going to return, just like the users, it's going to return a list of movies that exist in our database, right? Or whatever we have in our application. And then we also want to have, we also want to be able to grab a movie by its ID. So I'm going to say, actually, let's not get by ID. You know why? Because maybe you don't know the idea of the movie, which is different with user, because usually you have access to that and you only get information about user if you're authenticated. But with movies, you might just want to query information about a movie. So let's actually use name. So we're going to use the name of the movie as a way to get the movie. So name will be string like this. And what we want to do is we want to return back a movie type like this. And it's going to be required as well. Now, since we created these two fields, we need to come to our resolvers, and we're going to create two fields inside of a query type. One called movies, like this, and let's create the function real quick just for it. And the other one will be called movie, because it's the other field that we have in our query type. So I'm going to say movie like this. And it's also going to be a function. Now, I want to, just to separate them, I want to put like a comment over here. Movie resolvers. And on this one over here, let's just put user resolvers, just so we can kind of keep track. User resolvers. Now, one thing we need to notice is we currently don't have data for movies. So what I'm going to do is I'm going to quickly create some, similar to this one, I'm going to create some fake data for movies, and I'm going to come back in a second. Okay guys, so as you can see, I made a very quick list of fake data about movies. By the way, I didn't check any of this data, so like it's the year of publications are probably wrong. But I added a movie, example, Avengers Endgame. I added Interstellar, I added Superbad, and I also added a fake movie called PedroTech the movie that is going to be released in 2035, just so that I can say that it is not in theaters. But our list of movies is done, and what we want to do is we put it inside of the same file as the user list, but we want to return it at the bottom by just putting movie list as one of the things that we return in our exports. So now what we can do is we can access this movie list over here at the top by just importing movie list as well. And for the movies resolver, it's going to be very simple, similar to the users one. We just want to return the list of all the all the movies. So I'm just going to return movie list. And for the movie field, it's a bit different because it is going to be very similar to the user field. We're going to have to access the args to have access to the name of the movie. And I'm going to copy this as well because it's going to be pretty simple as well. It's going to be very similar. We're not going to get the ID, we're going to get the name. So we're going to say args.name, which is now the field that we're passing. And we're going to grab the movie, and we're going to use load dash to find from the movie list a field with, and I actually don't need to use it like this because now we're not converting anything from string to number. We can just put name equals to name, which, as I mentioned previously, we don't need to do it like this since both have the same name. I can just leave it like this. And at the end, I'm just going to return the movie. And you can see that if we come to our application over here and we change this over here, I'm going to uncomment this and I'm going to comment the query here. And we change this to get all movies, and I query, instead of the users, I'm going to query movies like this. I can specify that I can get everything. So I'm going to get the name of the movie, the year of publication, and the boolean saying if it is in theaters or not. And if I try to make this query, you should see every movie that we included is over here, which is amazing. It means it is working. Now, if we want to make a query that gets just a specific movie, we can say query get movie, and then inside of here we get the movie field without the S, and you can see that it already includes movie name, which is honestly amazing. I love how it does everything for you. And for the movie that we want to get, let's just get the name of the movie, the year of publication, and if it is in theaters or not. And now we delete the user ID from our variables down here at the bottom because we're not making the user query anymore. And for movie name, let's just put Interstellar like this because I just want to I want to get Interstellar. It's my favorite movie of all times. So we're not query just for Interstellar. When we click on Get Movie, you see that we get only the data for Interstellar. If I want to get for PedroTech the movie, it should only return data for PedroTech the movie. Which means that it is working. You just repetitively do this kind of stuff, and you'll get used to how like the process of creating your GraphQL API works. You create the field in your query type, and you go and make a resolver for it. Now, I created this type because I wanted to show you guys how can I nest a type, how can I relate a type called movie into a type called user. And the way we do this is we can actually come over here and add to the user type specific field called favorite movies, like this. And it will be a list of the movie type, like this. And I don't want to make it required. Definitely I don't want to make it required because you might not have a favorite movie. But this will explain a lot about GraphQL, because think about it this way. We just added a new field to our user type that includes information about movies, right? And that's important for many reasons. The first reason why this is important is because we don't want to actually just include favorite movies. Like we don't want to include movie. We don't want to include in our fake data over here for each user. We don't want to include directly our movie information. So like, for example, I don't want to copy objects related to movies and put it inside of a user. And the reason for that is because GraphQL is actually meant to whenever you have a field in a type that is of a type that is not one of the basic types, you should technically create a resolver for that field, explaining how you're going to get that data. So like, for example, we have favorite movies as one of the types for our user. So in our resolvers, let's actually create a resolver that is not from the query type, which is what we were doing before. We can actually create resolvers for the types that we created that are actually being used. So instead of saying query, let's actually start creating resolvers for the user type. And the first resolver we want to have is a resolver called favorite movies, which is going to tell the user that, like, whenever you want to query user and you want to get the information about favorite movies, how do we know which movies are the favorite for each user? So I'm going to create a function instead of our resolvers over here for user. And this function should specify which are the favorite movies for the specific user. So what I want to do is, right now we don't have data, so we don't know how to specify that. But just to show you guys, let's just come over here and return directly some fake data. And let's say that we only want to return movies that are they were published in between 2000 and 2010, something like that, right? How do we do that? Well, let's just use Lodash for our case. If you're using a database, you can easily select by a specific range. But for Lodash, we're just going to say .filter, and it will allow us to filter through a list. We're going to pass the movie list over here, and we're actually going to pass a callback function over here, which is going to grab a movie, and it's just going to return, depending if the movie dot year of publication, it is greater than or equal to 2000, and the movie dot year of publication is less than or equal to 2010. So you kind of get what I'm doing, right? This is not, you don't need to do this. I'm just doing this because I want to use it as an example. I'm only returning the list of users of movies in between those years. And this is just an example. We didn't specify in our data over here, in our fake data, anything related to movies inside of the user list. Now look at what happens when I try to query for a user. Over here, let me just comment this out again, and let me try to query for a specific user. I'm gonna query for the user that, like, any user, and let me try to pass in the favorite movies field. If I put favorite movies, I can specify now which information about the movie I want to get. So I'm gonna get the name, the year of publication, and if it is on theaters or not. Now, if we run this, what we should see is we should see that for the user that we get, we're only getting, we're returning back for favorite movies, maybe, yeah, Superbad and Interstellar, because those are in between 2000 and 2010. And if I run get user, you see that, oh, I forgot to put user ID as a variable. So I need to come over here and say user ID, and I need to change this to be one of the fields, right? So let me just get whatever user I want. Let me put 1 for John, and when I click get user, you see that not only we get all the data, but for favorite movies, it actually returns correct data. So we didn't put this data inside of our users table or our users list, but it still resolved and understood like which movies this user liked. Now, we obviously took like a quick, like an easy route over here, because we're specifying like this has nothing actually to do with the favorite movies of the user. But one thing you can do is you can have a separate table inside of your database related to movies, and what you can do is inside of the users table or whatever, you can include a field called favorite movies, and just a list of IDs. And then you can use that to query data from the other table and return it over here. So whenever you have a field inside of a type that it doesn't return a basic type, you can actually add resolvers for that field to that type and specify what that field will return. Now, this is kind of confusing. I honestly think so, because in the beginning when I started working with GraphQL, this was one of the things that made me go crazy. I hope you guys understand it, because we're going to be using a lot more of this later on in the series, and we're going to get more in depth on this as well. Previous episodes, we built out at least the beginning of our GraphQL API. You can see that we basically defined a schema that looks pretty nice. We have two types of users, or two types in our application. One is called type user and the other is called type movie. And we also have our type query, which allows us to query users and movies. So this basically taught you guys a lot. It taught how to use arguments while defining queries. I also taught how to create an enum, which was something that I wanted to show because, I don't know, I just thought it would be interesting to show in this tutorial. And then we also went over how to build resolvers for those functions. We're currently using this fake data list over here, which just contains a list of users for the user list. And there's also a movie list. And the resolvers basically just use that list to deal with the data, right? Depending on what they want to return. And we also have a resolver for the favorite movies field inside of user, which if you don't remember from the last episode, is important because favorite movies is a field inside of user which doesn't return like a basic type already existent in GraphQL. It returns a movie, which is a type we created. So we do need to specify how to get the favorite movies for this user, since in our fake data over here, this isn't included inside of the user list. So in the user that the data for the user that we get from our single database request, it doesn't include a field called favorite movies. So we do need to do that over here at the bottom when we inside of our resolver. So in this video, what we're gonna go over is basically how to work with mutations, which is the other root type that exists inside of GraphQL, similar to query. But as I explained in the first episode, a mutation, it differs from a query because it is basically used to mutate the data, to alter the data. So if you were using HTTP methods, a query would be like a GET request, and a mutation would be like a put, a post, or a delete request. It is used both like for creating data, for updating data, and for deleting data. Now, we're still using fake data for this tutorial. So what I'm going to do is, if I want to add a user, for example, to our data, I'm just going to push a new object inside of this user list array, and that's how we're going to add stuff into our data, right? And the similar thing will be done with the other types. Like, I'm going to show you guys an example of updating and deleting, just to show you guys how you can do that. And yeah, that's basically it. Before we get into the tutorial, if you guys could leave a like and subscribe, I would massively appreciate it. this tutorial series is actually getting a lot less views than I expected, but it's totally fine because I'm loving this. I love teaching like more complicated topics, and I feel like the reason why it's not getting a lot of views is because it's not a beginner video. So it makes sense that not a lot of people would see it, and it's probably one of the most worst performing series in my channel, but it's totally fine because I'm loving it. So don't worry. I saw some people commenting like, don't stop the series. I won't stop the series until I feel like it's a good point for it to end. And yeah, if you enjoyed the series, please leave a like because it will help a lot the channel. So now let's get into the tutorial. Okay everyone, so to start writing mutations into our project, the first thing we gotta do is, similar to a query, every GraphQL schema that wants to alter data, wants to add data, should have a type called mutation. So I'm gonna come over here and I'm just gonna add the type called mutation. And similar to query, what you do over here is you just write the name of the fields that are going to be able to mutate stuff. So for example, if I want to have a field which creates a user, I might just create a field over here called create user, something like this, right? And obviously, similar to like other types in GraphQL, you need to point out that it returns something. So what is commonly like the standard in GraphQL is whenever you create something or you delete or you update something, whenever you have a mutation with some sort of type, you just return the type. So if I'm going to create a user, I do all the logic to add the user to my database, or in this case, just to my fake data file over here. And at the end, I just return back the user for the following reason. GraphQL deals a lot with caching, so you need to update the data in the front end so that it is in the most updated state possible. And we'll go over this more in the next tutorials. But for now, let's just imagine that whenever we run a mutation, we've got to return its new updated values. So with the create user, it's something that we want to do. It's basically a mutation that will allow us to add a new user to our user list that we created. Now, one thing that we need to take into account is how do we know the data that we're sending? You can see that each user requires an ID, a name, a username, an age, a nationality. It doesn't require friends, but you can see that those are the ones required, and you can add those as well over here. So how do we allow the user to, whenever they make this mutation, they send the data required to form a user? Well, it's pretty similar to how you pass IDs and arguments for queries. However, the difference here is that it is a lot of data. So it would be kind of boring to just come over here and just add stuff like, oh, a name, which is a string, and age, which is an int. This would make this huge, right? And you can do this if you want, especially if it isn't a lot of arguments. But for creating a user, you pretty much need to put a name, a username, an age, and a nationality. So a common thing you can do is, instead of defining stuff like this, you can actually just come over here and say that create user accepts a user of type user. And then kind of makes sense, and you can make this required. But one thing I want to propose is that whenever you create mutations and you want to put arguments for mutations or anything that is big, I would use something in GraphQL called an input, which basically allows you to just define inputs for arguments whenever you have a field. So for example, we have this create user over here. Why don't I just come over here and say input create user input. Just open and close curly braces like this, and then we can specify which fields we want to use to create a user. Now, I understand that this might seem like it's redundant because literally what we're doing over here is we're just gonna copy and paste this over here, and the only thing we're not gonna add for the input is the ID, because obviously it's not, you shouldn't be passing an ID. You shouldn't need to know the ID whenever you create a user. But the thing is, there's many practical reasons why you need to use an input instead of just directly putting the type as the argument over here. And I'm gonna just change this before I explain to you guys. But basically, there's a lot of stuff that you can use and do with an input that you can't do with the type. For example, Imagine that this age variable over here wasn't required. It was just like you just accept an integer, right? Imagine that it just, since it's not required, I cannot pass, like I'm allowed to not pass an age, and this input would be completely correct. I would be able to create a user. Now, what happens if I want to say something like, this shouldn't be required, the user don't need to send an age, but if they don't send an age, I want it to default to like 18 years old. So if I want to do that, I can't do that with the type because that doesn't make sense. This is just the structure of the user. Whilst over here, if I want to do something like that, I can just say something like, this is equal to 18, and this over here should default to 18 if age is not passed. This is a little trick that works with GraphQL. Now in our case, we want to make age be required, and it also points out that you don't need to pass an ID, which is important, and that's why you should be creating an input like this. So now we're just gonna put this over here. We already did as an input, and we're gonna make it required because you should pass an input to create a user. Now, how do we deal with this? How do we go from this field being a mutation to actually creating and adding our like new data into our table, or in our case, our fake data array? Well, you can see that if I refresh my code over here, this is my API. It does give me an error, which is kind of weird. Let me go over here to my code. It's saying that, oh, I got an error, which is just saying that the type of create user input.friends must be an input type but got user. This makes total sense, and it was a tricky mistake. Over here, you can see that we do have a friends field, right? We do have this thing inside of our user called friends. But the thing is, inside of our input, we're saying that if you want to add friends, you just have to pass a type user. But that doesn't make any sense because we're just creating a user, right? So what I want to propose is when you create a user, you don't pass a movie or friends. We're going to do this separately. So when you create a user, all you need to pass is your name, your username, your age, and your nationality, which are the like the required types and that we created over here. And by the way, since I didn't specify, since nationality is like not a specific type, it's an enum that we created, I do want to be able to allow it to not be passed, to not be required. And the reason for that is because when you're working with predefined types that are like this, you need to account for the fact that maybe someone, or for some reason, passes Canada but without like capital letters like this. And if we make this required, completely required, it will give us an error if it isn't the correct, like exactly how we define over here, which is something we might want to avoid. So what I'm going to do is I'm going to say the nationality is a nationality. It's not required. But if no one passes a nationality, let's default it to Brazil. And yeah, I'm just choosing Brazil because I'm from Brazil. But yeah, this is just an example because I find this really cool, and I just wanted to show you guys how this would work in a real application. So our user input now is correct. Let's check. You can see no errors are occurring. Let me refresh over here. You should see that if I just remove this over here, I'm actually just going to remove this. I'm going to remove the get movie as well from the last episode. We still have our query over here, and it's working perfectly. If we want to run a mutation, we really can't do anything about it. And the reason why we can't just run a mutation right now is because we created the mutation type over here, create user, but we didn't actually write any resolvers that actually do something about it, that actually gets this input and creates a user. So to do that, let's come to our resolver.js over here. And similar to how we have a query type inside of our resolvers, and we have all the resolvers for the fields for the query, and we also have a user type over here for the user. We want to have a mutation type inside of here. So I'm gonna put it right below the. Actually, I'll put it below the user, like down over here, and I'm just gonna call this mutation, and it's gonna be an object, which is just gonna include like all of the functions related to mutating the data. So the first function that we're going to work with is the one that we created. It has to be the same name. So it has to be called create user. And we're going to come over here, just create the function, and it should be fine. Now, one of the things is when you create a user or when you write any mutation, you'll probably need to like access some sort of argument to the function. So similar to how we accessed like the arguments for the fields that we're requiring, the required arguments, we're gonna do the same thing. We need to get these two things over here from our function, and now we can use this args to be the new user. So what I'm gonna do is I'm just gonna say const user is equal to args.input, like this, input, because if you recall, we created over here the argument is called input, like it has a type input, and this includes everything that we want to use. So in order to access this, I can say args.input, and now I get the user info that exists inside of here. So now just to see if it's working or not, let's just console log this like this, and just console log the user. It will give us an error, definitely, because we're not returning a user like we said we would. One thing is I'll not make this required. I'll just make this not required for now. And let's come over here and let's try to run this mutation to see if everything is working. So in order to run a mutation, you do something very similar to a query. You come over here to where you're going to make the API request. You're just going to run mutation. Then we just open and close curly braces, which is a bit different from a query because we were using the name over here. We could still give a name for this. So I can just come over here and say something like create user as the name of the mutation. And then inside of here, I tell which of the fields inside of the mutation type we're trying to access. In our case, we just have one field, which is called create user. So I can just say create user over here. And you should see that it will, because we're using the Apollo GraphQL Studio, it will automatically generate some of the stuff for us. So you can see like it generated this parentheses over here and all of this information inside. I'll just explain really quickly what they mean. So when you define a mutation like this and you give it a name like create user, you first grab the variable, like you create a variable by using this money sign over here and set it equal to be of the type create user input. And that means that now we can pass the input data over here, similar to how when you're going to make the request in the front end, you're going to pass the data as a variable to the mutation. Then inside of here, we just say that we call the mutation and we just set the input to be equal to the variable that we created. I know this is kind of confusing, and believe me, it's going to make a lot more sense when we start working in the front end. But for now, this just go with the flow. We're just going to pass the data inside of this variable, and it should be accessible inside of our resolver. So for now, let's just write something like I want to get an ID, I want to get the name, and I want to get the age. And the data I'm going to pass, it has to be of a user type or a create user input, which just asks us to have name. So let's just pass a name like this, name. I'll just make it Pedro. Then let's pass age. So I'll just pass age, which would be 20. Oh, by the way, this has to be JSON, so we do need to double quotes this. And let me just open this up a bit. The final one, it's actually not the final one. I think it's username. So username even comes before. So I'm just gonna say username like this, and I'm gonna pass PedroTech. And then finally, we're gonna have nationality, which technically we don't need to pass. So actually, I won't pass just to see if it defaults to Brazil. Now, when I click create user, you see it gives us no. It did work. Status 200. It did work because although we didn't return a user, because in our resolver we're currently not returning a user, we should see the data that we passed over here being console logged in our server. And as you can see, this is exactly what happens, and it actually defaults the nationality to Brazil because although we didn't pass any value for it. So we know that it's working. We know that we can access the user by saying args.input, which is amazing. So now all we had to do is just add this new user to our fake data array over here. Or if in your case you're using any database like MySQL or MongoDB, here's where you add a new field to your database table. So for us, what we're gonna do is we're just gonna come over here. We're gonna grab the ID of the last user. This is something we have to do because we want to increment the ID by 1 every single time. So I'm just gonna say const last ID like this is equal to user list, and I'm gonna grab the last one. So I'm just gonna say I want to grab the user list dot length like this -1. So I'm just grabbing the last element and I want to grab the ID from it. And this is the last ID. So what I want to do is I want to construct, I want to add to this user type that we just grabbed from the input. I want to say user.id. I want to add a new ID to it and set it equal to last ID plus 1, because now if the last ID was 5, now the new user we add is going to have an ID of 6, if that makes any sense. And then finally, I think this is all we need, because now all we have to do is we just have to say user list dot push, and we're going to add the new user to the list. And at the end, we just return this user. Now let's see if this is working. If this is working, what should happen is, you can see over here, if I query all the users, like over here, I'm just gonna also remove this, you should see that there's no PedroTech over here. Oh no, I'm getting all the movies, not users. I need to grab all the users. So I'll just say get all users, and let's just query the users field over here. And I'm just gonna delete all of this because this was the previous query. And what I really want to do is, inside of here, I want to grab the ID, I want to grab the name, and I want to grab the age, just for now. You can see that all the users, none of them, just one of them is called Pedro. So what I'm going to do is I want to add a new user. The name is not going to be Pedro. The name is going to be Elliot, and the username is going to be Elliot123. The age can be 20 as well, and I won't pass a nationality again. So what we're going to do is we're going to just uncomment the mutation, and let's run this mutation again to see what happens. You can see, first of all, we do get the user back because we're now returning the user at the end of the mutation. And let's uncomment this, and let's run the get all users again to see if the data was actually updated. And you can see that it was. We now have an Elliot, and the ID is 6, and the age is 20, which means we are actually adding some data to our table. Now, we're just doing this very simply by just pushing it into array. And if you're using a database, it should be a little bit more complicated, but at the same time, just put the logic for like inserting into a database table right over here, instead of having to do like all of this thing over here. This is just because I'm using fake data. And yeah, I hope you guys got this. And this is going to be the flow of creating mutations from now on. Now, since we went over our first mutation, I just want to go a little bit faster for the next ones that we're going to create, because it's going to be pretty much the same. So for example, we have a create user. Let's just add a update user, right? Because it might be something that we want to do. Let's instead of being update user, because should we do update user? Actually, let's not do update user. Let's just do update username, something like this. So we just want to get a new username and update that user, that user's username. So to do that, what we got to do is we got to create a new input over here, and this input is going to be pretty simple. We're going to call it update user input, or update username input, like this. And what it requires is, number one, an ID, like this, because we want to get the ID of the user we want to update the username. And then it also requires the new username. So let's just write here new username, like this. And it's going to be a string. And what we do is we just put input as a field, and we say that it is of type update username input. And at the end, we should return a user, like this. Now we just create the resolver for it. The resolver is going to be pretty simple again. We're going to just copy and paste this over here. What I want to do is I'm just going to grab the ID for the user. I'm going to delete this over here, and I just want to grab the ID of the user we want to update by saying args.input.id. And then I also want to grab the new username by saying new username is equal to args.input.newUsername. We could actually have done this a lot easier. We could have just done something like this. Set it equal to args.inputs, and then just grabbing the ID and the username by destructuring the object. This is a little trick that I would recommend for you guys. Instead of having to write new lines, do everything in one of them. And now we have access to the ID and the new username that is going to be passed in the argument. So what do we do with it? Well, the first thing we want to do is we want to, first of all, find the user with this ID and just change its username. So to make that, I'm actually going to do it pretty simply. I'm just going to grab the user list. I'm then going to for each like loop through the username or the user list, and I'm going to grab each user over here, and all I'm going to do is I'm just going to ask if user.id is equal to the ID that we want to update. Then I want to say that the user.username is equal to the new username, like this. And this should be fine. We're just looping through the user list, checking to see if any of the elements in the user list has an ID equal to the one that we want to update. And if it is, then we want to update the username to the new one passed in the arguments. And at the end, after everything is done, I want to do this right here. I want to create a variable called user, and it can be null, right? We'll initialize it like this. And if we eventually find a user and actually that we want to update, then we'll just set this user equal to user, or actually I'll just call this user with change. Actually, I'll just call it user updated. It makes more sense. And I'll set this equal to the user that was actually found and that has the username updated. And then at the end, we just return the user updated. Now, there's no guarantee that we're going to pass in the front end an ID that actually exists in our table or in our data. So this over here can be null, which makes sense because we just made our return type to be not required, which means that we don't really need to send something back, as long as this allows us to handle errors more easily. So let's test to see if this is working. Let's come over here to our Apollo GraphQL Studio. Let's get all users. You see everyone is working perfectly. You can see Elliot disappeared because we restarted the server, so that's right. But one thing I want to do is I want to update Sarah's username. Let's just grab username over here. Let's see what is Sarah's username. It is currently Cameron. I want to update it. So to do that, I'm just going to call a mutation over here. I'm going to just copy and paste it like this. But instead of create user, I'm going to call it update username. And instead of being the create user, I'll just say update username. Oh, damn, I just realized this got pretty confusing. So I'll just delete this. I'll say mutation, update user, like this. And then I'm just going to say update username as a field, and you can see it filled in everything perfectly. Now we specify which fields we want to get from the user who was updated. I'll just grab the ID. I want to get the username, which are the two fields that actually matter. So if I come over here and I just remove the create user input, and instead I put an input for the update user, I need to pass an ID. The ID for Sarah is 3, so I'll just pass 3 over here. Then the username for Sarah is Cameron, so we want to update that to, let's make her username, I don't know, Ward, like this. So this is the data we're passing. Let's try to run it. It actually didn't work because it said that the field new username required, oh, I called it new username, not username. So I need to say new username, like this. And now that we have the correct name for this variable over here, let me just click on update username, and it doesn't seem to work, which is kind of weird. Let me just take a look at the code. I don't see anything. Oh, actually, damn, I already found the error. So we just copy and pasted the create user mutation function and forgot to change this to update username. So this needs to be the same name as the name we had for our type definitions. So now that this is done, if I run this, you should see that we get back the data. And if I actually come over here and I try to get all users again, you should see that Sarah now has a username Ward instead of whatever the username was before. If I want to update Pedro's username to PedroTech, I can just come over here, uncomment the mutation again, and pass Pedro's ID as 2, and then I'll just come over here, change this to, I don't know, Pedro 123, and when I click update user, we should see that it sends back the correct data. And if we query all users again, it should show that both Pedro and Sarah has updated usernames, which means it's working. which is awesome. And we basically are able now to update stuff inside of our data. Finally, to keep the episode short, I'm just going to really quickly show you guys a delete mutation, which is going to be pretty simple. The first thing I want to do is just delete all of this because it's kind of annoying me that we have a lot of stuff inside of our operations, like little tab over here. Then I want to come over here and I just want to add a new field to our mutation. Let's call it delete user, and or I'll just say that it will return a user, the user that was deleted. But one thing I want to point out is that when you want to delete a user, usually you just have to pass an ID, right? It kind of makes sense. You just want to pass an ID and delete the user with that ID. So I'm just going to grab an ID. I don't even care to create an input because in this case it's just one field, so it doesn't really matter. We don't need to create an input type just for this. So now to finally delete stuff, I'll just come over here to our resolvers, add a delete resolver by saying delete user and just adding the function. We do need to grab the parent again because we need to get the args. Because now if I need to get the ID from this args by saying const ID equal to args.id. Then now that we have the ID, in order to remove a user with in a list, in an array with that specific ID, we can just use the low dash function called remove. So we can do something like this. Just come over here, say dot remove, then say that we want to remove it from the user list, and then it will loop to the user list, and we'll just say that we only want to remove the users which the user.id is equal to the ID of the user we want to remove. In our case, and as we did before, the ID will come as a string, so we do need to convert it into a number by just saying number ID, like this. And this should remove everything. Since we're not keeping track of the user, and for simplicity reasons, I'll just return no right here. We don't really care that much about the user that was deleted, and that's kind of most cases this happens. But since we just return everything, it seems that we removed it from our array. Let's test it out. How do we get this to work? Well, what we can do is we can just come over here and say mutation. And for this one, just to show you guys, you don't actually need to write the name of the mutation or query. You don't need to give this name. This is more best practices, and it's easier for organization, especially when you're working in the front end. But what we can do is we can just say mutation, then write delete user, and it will actually generate a mutation without a name, as you can see over here. We do say that we want to get the field called delete user, and that we need to pass an ID. So I'm just going to delete the old inputs that we had over here for variables and just leave the delete user ID. And I want to delete the user with the ID 4, Rafe. I want to delete Rafe over here. So I'll just pass 4. And for the user that returns back, right now we're returning null, so I'll just put ID over here just for it, or else it will give you an error. And let's try running this. If I click run, you should see null because we are returning null. And if I try to run the get all users, which by the way, if you want to alternate between stuff that you wrote in your operations tab over here, you don't really need to comment them out. I can't believe I actually just found out. It's because the Apollo GraphQL Studio is actually pretty new, so I'm still pretty new to it. So I just found out that you just need to click like this, and it will keep alternating between whatever operations you want to make. So we just deleted the user. Let's try to get all users again, and you should see that Rave is not here because we deleted. If I try deleting Kelly over here, you should see that Kelly doesn't exist anymore. So this is amazing. It means our mutations are working. It means that our GraphQL API is pretty much in a pretty good state, right? We have some cool queries. We have some cool mutations. We have some complicated types. We talked a lot about inputs. We talked a lot about different types that you need and how to build your resolvers like this. And yeah, I'm really excited for how the state of the series is. In this video, we're actually going to start transitioning into creating a full stack application. So we've dealt a lot with backend stuff. We kind of know how type definitions work. We understand how queries and mutations work. We understand how resolvers work, and it's all chill. But the thing is, the whole point of GraphQL is to facilitate how the front end is able to query and handle data from the backend. So it is important for us to just start working on the front end so that you guys can get introduced to that topic. And if I need to introduce new topics from the backend, I'll just introduce them after we already have a front end. So in this video, we're going to create a new folder over here, and it's going to be called the client folder, like this. And this client folder will include everything related to the front end, similar to how the server folder includes everything related to the backend. So I'm just going to open this up over here. This terminal is in the backend and it's running our server. I'm going to open another terminal and change my directory to be the client folder, like this. You can see it's the client folder. And I just want to install a simple React application into this project. And to do that, I'm going to run the command npx create React app, like this, and then a dot at the end, which basically means that I want to create my React application inside of the client folder. Now, what we're going to be using as our communication library to use GraphQL in our front end, it's going to be called the Apollo client library. I'm going to show you guys this over here, Apollo client. This is it's probably the most famous front-end GraphQL library out there, especially for React, and it allows you to do so many things. You can just look over here and see how you can write the syntax and how everything works. But we're going to be using this throughout our project, and it's used in many companies, so I feel like it's a good learning experience. So as you can see over here, it has finished just creating our front end. We have this simple React application over here. I'm just going to close the backend stuff because we're going to focus on the front end. And what I like to do whenever I start a React project, as many of you guys might know, is I like to delete the test file, the index.css file, the logo, and the test file, because we're not going to use any of them. So I'm just going to delete all of them like this. And now let's come to our index.js, delete the import for the CSS file we just deleted, and then come to our app.js and just delete the logo over here and also all of this stuff over here because we're really not going to use it. Now let's just write over here hello world and try to run this application by coming over here and saying npm start. When we run this, it should run and open it over here, and it should be an empty screen, an empty white screen with hello world written in the middle of it. So let's see. You can see, yeah, this is exactly what happens. I'm going to zoom in a little bit just so that everything becomes clearer. And what we want to build is, we really don't care about what our front end is. We just want to be able to fetch data and create data, right? So the first thing I want to be able to do is fetch data. So over here in our fake data, we have a list of users and we have a list of movies. And in our schema, if we see over here, we have two query types. We can get a full list of all the users. We can get a specific user. We can get a full list of movies, and we can get a specific movie. I'm going to show you guys how to do each of them respectively in their own. But the first one we're going to work on is how to fetch lists of users, right? Or list of movies. We can do both of them, but it's going to be pretty similar, so it's totally fine. So to do that, we actually need to tell our React application that it's going to accept and it's going to make a connection to a GraphQL API, so that whenever we make an API request, it is using all the GraphQL standard methods to make that request and fetch that data. So in order to do that, we're going to come over here to our highest level component, which is the app.js. And inside of this, what we want to do is we want to initialize first by importing some stuff from the Apollo client library. Now, as you can see over here, we haven't installed Apollo clients, so we need to do that right now. So I'm just going to open another terminal over here, and let's clear this terminal. Let's go into the client folder, like this, and let's start installing all the packages we need. So technically, the only library we actually need is the Apollo client library. And by the way, this is Apollo client version 3. It was very different the way you did all of this stuff, including how you import the name of the libraries and everything from previous versions. So keep in mind that this is the most updated version of GraphQL, or not GraphQL, but the Apollo client library. So just keep that in mind. So I'm just going to come over here and say npm install, and I want to install the library at apollo/client. And this library over here is the one that is going to control our whole front end and make it work with our GraphQL API. Now, as you can see over here, I pressed enter and it's installing everything, and it seemed like our library just finished installing. So what we want to do is we want to come here at the top and we want to try to import from @Apollo client again, and you can see that our thing actually autocompletes, which means the package is installed. Now, what we want to import from the Apollo client library is the following. We first want to import an Apollo client like this. It's a class that is created by the Apollo client library. Then we also want to import something called in-memory cache, which is also a library, and I'll explain a little bit later. And then we want to import Apollo provider, which is also a class that comes from the Apollo client library. What we need to do is this Apollo client over here, this class, it basically, whenever you create a new instance of it, you're telling GraphQL that you want to use this to connect to an API. So for a connection, you need an Apollo client an Apollo client object or a class instantiated. So to do that, we'll just come over here and we'll just say create a variable called client and set it equal to a new version or a new instance of the Apollo client class like this. And this class takes in a few arguments. And the way we pass it in is as an object like this. And the two arguments that it takes in is basically the first one, some sort of cache that we need to specify, and I'll go over this in a bit. And also a URI, which is basically the link, the URL to where your GraphQL API is running. So if you're using a public API, you can just put it over here. But if we're using our own API, for us, it's basically just http:/localhost 3001, because that's where our API is running. And this should tell GraphQL that this is where our API is running, which means that it's going to actually connect to our API and make it work. So I also need to put the /GraphQL because if you recall, GraphQL always runs on the /GraphQL endpoint. So we need to specify which one it is so that our library understands what it's doing. Then for cache, what happens is the Apollo client library has a really good state management aspect to it, and it allows you as well to cache information and data into your browser, right? So basically, if you fetch some data and you change a component, for example, move in your route system, and you go back, you want the data to be kind of updated, right? Or you might want the data to be the same thing. You don't want to need to refresh the page every time you move. Because think about it this way: if you render a component and you go back to another component, making a request every time you render a component might be overkill. And if you want, you can just cache your data, and the data will maintain the same because probably there weren't any changes to the data to begin with. So this is basically what cache is in GraphQL. And with GraphQL, with the Apollo client library, they have an option which is basically just determining that your cache is in memory, which means it's gonna literally save that information or cache the data in memory. So we'll just say that our cache system will be in memory cache, and we can just declare it like this, and GraphQL will know exactly what to do. So now that we have this client variable over here, we basically just declared how our structure of our API will be and what API we're communicating with. Now what we need to do is we need to wrap all of our components that should be able to make a request to GraphQL with an Apollo provider component. So I'm just gonna say Apollo provider over here and just wrap it around with the highest level component and just wrap everything around with it like this. And on the top over here, we need to pass and specify a client because it takes a client as a prop. And the client that we want to pass is this client that we created over here. So I'm just going to paste it inside of here. And now what should happen is we should establish a connection with our GraphQL API, and our project is kind of ready to start making API requests to our GraphQL API. So now that we have created this, let's actually start by making our project be able to accept such requests, right? So what we want is over here, I just want to have a div, right? And I just want to say something like have an h1 which says list of users, and I want to fetch the data and then just display the list of users below this. So right now, all we have is this thing saying list of users, but it's totally fine. I'll show you guys how to fetch the data now. So what we want to do is we want to import some stuff from the Apollo client library. So the first thing I want to import is I want to import the UseQuery hook. Now, what is UseQuery? Well, the UseQuery hook is extremely important for the Apollo client library because it is the hook you use to make queries to your API. Similar to that, there is a UseMutation hook which allows you to make call mutations into your API. There's other hooks as well, and you should definitely learn them. I'm going to show you guys one of them, which is the useLazyQuery hook, which is also very important. But for now, let's just focus on UseQuery. Basically, what UseQuery does is it fetches some data from an API, and it does it whenever the component renders. So in our case, whenever this component over here renders, we should see the data being displayed immediately without us having to call any action or doing anything like that. So to use the UseQuery hook, we'll just come down here at the bottom inside of our app component. And actually, what I want to do is I want to create another component to fetch all the data. So I'm just going to call this display data. The reason why I want to do it is because I don't want to like put everything into a single file and make it confusing. So I'm actually going to just import the UseQuery over here at the top, and I just want to come over here and just render the display data component like this. And you see it was automatically imported, so it's totally fine. In our display data over here, I want to import from the Apollo client library. So from Apollo client, I want to import the UseQuery hook. And inside of here, I just want to say const then I want to open and close and say UseQuery. And what we pass over here is the query that we want to make. Now, what I want to tell you guys is it's a bit confusing. If you recall in the second episode of this series, I showed you guys how to fetch data from the front end whenever you don't you just have an API and you want to fetch data. And throughout the series, we've been using the Apollo library, which I'll just show you guys over here, localhost 4000, which is actually, oh, I just realized our API is running on localhost 4000. So I need to change this over here to be 4000 and not 3001. I'm sorry about that. So I'm just going to say 4000. Throughout the series, we've been querying data and fetching data using this sandbox, right? So to query data, we just say something like this, and it gets us all the data. Well, it's basically what we need to do right now because we are now fetching the data from the front end. So to do that, we need to write some GraphQL similar to this over here to specify what we want to query. Now to do that, we create something called a GQL statement. So we need to import something called GQL from here. And to create a GQL statement, all we do is we come over here, we say const, then the name of our statement, which by standard, it's usually something like query all users, like this. And by the way, I'm not really sure why we use all capital letters. I've just always seen it like this, and I'm not completely sure why this is a standard. But feel free to do something different. I always do it like this, so I don't know why. But yeah, that's the thing. You say you call it query all users. You set it equal to GQL, and then you open and close backticks like this, and you write GQL code inside of here, similar to what we've been doing in our type definitions over here, as you can see. So what we write over here is exactly what we wrote over here to query all users. We just copy and paste it over here, as you can see, and we just specify, okay, I want literally to query all users, so I need to specify which field from our root query we want to get. In our case, it is the users field because it is the field that we want to query, and we also specify what fields inside of the user type we want to get. So we can get an ID, an age, a username, and a name. Now, it is very similar to what we've been doing. So when you finish this over here and you create this query, you basically just come over here, you copy this, paste it over here, and it will make the request. Now, how do we get the data? How do we know if the data, like if it failed, if there was any errors, that kind of stuff? Well, the GraphQL, the Apollo client library, allows you to get all of that information very easily by using the UseQuery hook. For example, if I want to get the data, I can just get the data out of it, and this data variable over here should display the data. So let's actually test it out. Let's say if data, so if we have the data, then I want to console log the data. Let's see if this will work. Now, if I come over here and I just refresh my page, let's open the console as well. If I just refresh my page, should we see the data? And yeah, we see the data. So you see, it console log the data, it console log the field users, and each user is included over here, which means that our API and our frontend are correctly connected, and we're able to see all the information that we're sending from our backend. So this is amazing. It means everything is working, and it means that we can continue just building more stuff. So what else can we do with this UseQuery hook? Well, we can also get information, for example, if the data is loading. So if the data is loading, maybe we want to display something like this. Instead of returning the data down here, we can return an h1 tag saying data is loading. And you'll see that whenever I refresh the page, for a split second, it will say data is loading, because it is, while the data is loading, while it's fetching the data, it should display this information, which is really cool, and it's a really great addition from the Apollo client library. Now, in this case, what you might want to use is like a loading spinner or a loading bar or something like that. But for me, I'll just leave it like this, and it's totally fine. We can also get any errors that might occur by just grabbing the error variable over here. And what you can do is you can do something like this. You can say if error, then you maybe just some error handling, or just display something saying, oh, some error occurred. For me, I'll just console log the error just to see what happened. And I don't think any errors are happening, so that's totally fine. But the important thing is that we now have the data available for us. So how do we display this data? It's a list of users. So what we can do is, inside of our return statement down here, where we're just like returning UI stuff, we can just come and say, if the data is available first, because remember, for a split second, data might not be available because it's still fetching. So we always need to ask if the data is available. Then I want to map through the data like this, data.map. And inside of this, I just want to create a function which basically says that whenever, for each element in data, I want to return over here an h1 tag saying, actually I'll return a div just so we can actually display a lot of information. So I'll say I want to return a div, and this div will include the following. It will include an h1 tag that says name is equal to, and then we need to grab each item. So I'm going to say user over here, and I want to say that the name is equal to user.name, because it is one of the fields that we're querying, right? We're grabbing the name, we're grabbing the age and the username. Then I want to do the exact same thing, but for the age and the username, which are the other two things that we want. So I'll just grab over here the username, user.username, like this. And we'll do the same thing for the age and say user.age. And you should see that now it should be displaying, but it isn't. It is saying that data.map is not a function, which is kind of interesting. And I know why this is happening, but if we recall in our console log, I don't know if I deleted the console log. I did, but basically in our console log over here, I'll just do it again like this. If data is equal to data, let's just console log data. Look at what happens. It will basically just the data that we're receiving isn't just an array. It's an object containing a field called user and then an array of the data. So instead of saying that we want to map through data like this, we want to say data.users or user. Let me see which one it is. It's users.map, because we want to specify which field from the data has the data that we want. So now it should be working. You can see that it is actually console logging each user with its name, its username, and its age, which is amazing, right? It's working perfectly. Now we can specify more fields if we want to. For example, if you recall, in our user type there is nationality, so I can just come over here and say nationality like this, and we can add a new field over here, which for some reason should show the nationality. Let's see if this works. Nationality and user.nationality. And you should see that each user should contain a nationality below them, which is really cool as well. You can specify everything you get from the backend right from the frontend, which is the whole point of GraphQL, right? So now that we know how to do this, now that we are able to query our data, let's add another one really quick, just so that we can use what we just practiced and be able to query movies. Try to do this without me showing. I'll just show right now, but try to pause the video and try to do it on your own. Let's try to query this field over here. Where is it? It's over here, the movies field, and let's see if it works. So for us, it's going to be very simple. All we're going to do is we're going to come over here. We're going to create a new GQL statement. Let's say query all movies, like this. And then instead of get all users, let's just call this get all movies. And we can just specify that we want to grab the movies like field from our API. And it will return a list of movies. So each movie can have a name, a year of publication, and an is in theaters Boolean. So I'll just grab the name of the movie for simplicity reasons. So I'll literally just grab the name over here. And what we do now is we just create a new UseQuery hook. And instead of passing the query all users, we pass the query all movies. Now one thing you might wonder is, okay, but these variables all have the same name. So what do I do now? A very common thing to do is just give them different names. And to give different names, all you have to do is you see this data over here, right? This is a variable called data. If I want to change it to movie data, I can just put a colon over here and change it to movie data. And now the same data will be in this variable. I'm going to do the exact same thing for this over here, movie loading. Actually, I won't show any loading and error. I just want to grab the data. And for movie data, I'll just come down here at the bottom, below the data that we're mapping over here, and I'll do the exact same thing. I'll just say movie data. If it's true, then I want to say movie data dot movies, because we need to access the movies field from the query type, and then I want to map through them, and for each movie I want to just return an h1 tag with the movie name. So I'll just say name or movie name, something like this. Movie name is equal to movie.name. And now you should see that at the bottom over here, right below all the users, we should get all the movies in our data set, which is amazing. It means everything is working. Now we've done a lot of stuff. We've actually worked with just querying a list of stuff that we have in our API. How do we actually just query stuff individually? So we have these types over here, for example, where we pass an ID and we can query a specific movie or a specific user. But how do we specify and how do we actually query information based on an action, right? Because right now we're just making a query and fetching data whenever we refresh our page or our component is rendered. But how do we fetch data on command or on click? Well, to do that, I'm gonna create a new component over here. Or actually, no, I'll just do it down here at the bottom. I'll create a div over here, and I'll just put an input. And this input over here will be of type text, like this. And it will contain the movie name that we want to search for. So for example, I can just go over here and say something like placeholder. And I just want to specify something like Interstellar, just to give an example of how you write a movie name, like this. And then down here at the bottom, let's just add a button, which when you click on this button, it's supposed to make a request and fetch the data from this movie that we wrote over here. And I want to just display the data down here by creating a div, and then we're going to display the data that we receive inside of here. Now, how do we do this? How do we fetch data on command? Well, the first thing we need is the actual whatever the user wrote over here. So how do we grab values for inputs? Well, it's very simple. We need to basically just create a state. So I'll create a state over here at the top, and I'll create the state and call it movie searched or set movie searched, something like this. And this will be equal to the use state hook, like this. And we need to import it. was actually automatically imported, so it's fine. And this over here should be a string and should start as an empty string. Now what we do is we just come over here to our input and we say that whenever there's any change to our input, we want to detect that change, grab the event, and for each event, for each change, we want to set the movie search to be equal to event.target.value. And this will alter the value of the movie search state to be equal to whatever we wrote in this input over here, which means that I can just write interstellar, and now the state is, like the value of the state is interstellar, which is great because it's what we want to search for. So now what we do is we come over here at the top and we want to import another hook from the Apollo client library, and this hook is called the UseLazyQuery hook. And lazyQuery just means that we want to hook for data like on command, right? We want to only want to fetch the data whenever we tell it to fetch. And it's very similar to the UseQuery hook. We just come here at the bottom, we say something like const, then we open and close brackets instead of curly braces like this. We set it equal to the UseLazyQuery hook, and we do need to pass a query over here, which I'll do in a second. But what happens here is you can grab information from the query like this over here. But first you need to define the name of a function which we're going to use to call to fetch the data. So for example, if I want to fetch this data, let's give a name for a function that would do that. Let's call it fetch movie. And then over here we can do the same thing we did over here. So we need to first pass the name of the function and then what we want to grab from the data. So I can grab the data, I can get any errors, and those are the two that I really want to do for this one. So I'll call this I don't know, movie search data, and I'll call this movie error like this. And this function will pass it down here at the bottom, so that whenever we click on this button, so we'll pass an on click, we want to call the fetch movie function. And it's that simple. You just basically specify a name of a function which you want to call to fetch this data, and you can call this how many times you want and it will fetch the data every single time. So this is basically it for the UseLazyQuery hook for setting it up. Now we need to write our query that it's going to be used to fetch the data. So for getting a movie, it's a bit different from this one's over here, because if you recall, we need a variable, right? We have a variable over here, which is the movie name that we need to pass. So we need to specify that whenever we write our query over here. So I'm just gonna say query, and then I want to say get movie by name like this. Oh, I completely forgot to that this is not query, this is const. And I want to specify it like this and set this equal to GQL, and let's open and close backticks. And now what we want to do over here is we want to write a query similar to what we've been doing like over here, where we specify a variable, we give it its type, and then over here we just use that variable and pass the value over here. So to do that, we'll just come over here and say we want to query and give it a name. Let's say get movie by name, similar to what we wrote above. But then we need to pass parentheses to say that we need to pass an argument or variables to this function. So similar to this, we declare a variable name by adding like a money sign. So I'll just say money sign, let's call this name, and give it a type, so it's going to be of type string. Then over here we call the type that we want to query, which in our case it will be the movie type over here. And when we query the movie type, we specify that we want our name argument, so our name variable over here, to be equal to whichever variable we pass to this query. So we'll just say money sign name. Now I know 100% that this is confusing, and it is very confusing in the beginning, but just continue practicing on this. Just keep making more queries and working on more examples, and it will make sense. Basically what we're doing is we need to first define a variable name over here, give it its type, and then when you query the field, you pass the variable that you defined over here to its value. And the reason why we do this is because we need to pass the value of this variable from outside of this query. we really want to do this, right? We want to set the name of the movie we're searching to this state over here. So how can we do that if the query is predefined over here? We couldn't just come over here and set something like the name should be Interstellar. We want to actually make this be dynamic, and the name that is searched is the name that we want to search and that the user is actually trying to search. So to do that, we need to do it like this. And we then just specify which fields from the movie type we want to get. Now we remember that the movie type includes this fields over here. So I want to grab the name and the year of publication for simplicity reasons. So I'll just say name and year of publication, like this. Now this is fine over here. I think this query should work. Let's just copy the get movie by name, paste it into our use lazy query, and now it knows exactly what it needs to, or what it's supposed to fetch. So what we want to do is we want to use this data variable over here, down here at the bottom, and like right over here. And we want to, whenever we get the data, so if data, or actually it's not data, it's movie searched data. So whenever movie search data is equal to true, then we want to just display an h1 tag. Actually, let's display a div like this. And this div should include the data that we want. And the data that we want is an h1 tag, including the movie name. And the movie name will be equal to movie search data dot movie, because movie is the field that we're querying, dot name, like this. And we'll do the same thing for the other one, which is the year of publication. So year of publication, like this, and we'll say movie search data dot movie dot year of publication. And now when we save this, it should not be working. It is not displayed. Even if we click on this over here, it will fail. And the reason why it will fail is because we're actually not passing the variable, so the movie name, to the request that we're making over here. Now, how do we do this? How do we pass this movie search state over here as the variable for this, so that it is actually querying the correct movie? Well, there's two ways to do this. You can either pass it over here by just saying, just opening an object and saying variables like this and just passing the data, but I usually like to pass it through the function. So there's this function over here called fetch movie, and instead of just saying on click fetch movie, we want to say that on click we want to call the fetch movie function with the following arguments. So I want to pass a variables property over here, and for the variables we open and close curly braces to define that there might be multiple variables that we're trying to pass to our query, and we just specify which variables we want. In our case, we want a variable called name, and the value of it will be movie searched, the movie search state. Now we're actually fetching the correct movie depending on what we wrote on this input. One thing that I just realized as well that I need to fix is, I mentioned this in the first or second video. When you have something like this over here, where we're using variables like this, the name actually matters. If you're going to give a name to this, it needs to be either like empty or just the name of the field. So in this case, it's movie with a capital letter. So something like this. And now what we can do is we can just come over here and try to test to see if it's working. So let's just come down here and search for Interstellar like this. And when we click fetch data, you can see that it opens up a little bit more space because now it shows the data for the movie we searched. Now, one thing that is important to understand is if I try to search for something that isn't a movie, it will break. You can see it doesn't show the data, but we do want to see what the error was. Obviously, the error was caused because we try to search for a movie that doesn't exist. So what we're going to do is we're going to check to see if this movie error variable over here exists, and if it does, I just want to console log it. So let me say if movie error exists, then I want to just console log it. And also, I'm going to console log the movie error like this. And also, maybe do some UI error handling. Like, if this is not true, like if this is true, we want to display this. But if movie error is true, then I want to display an h1 tag saying something like, there was an error fetching the data. And when I save this, you can see that if I refresh my page, and I try to search for something like interstellar, we should see that it will work. But if I try searching for something like whatever this is, it should say there was an error fetching the data. And if we go to our console, it should actually console log some sort of predefined GraphQL error, which is this one over here. It basically just says cannot return null for non-nullable fields. So we tried to query a movie, but it didn't actually return the movie. That's what it's basically saying. So now we have our beautiful app over here, which I honestly looking right now, it kind of seems confusing, but we're able to query data from lists. We're able to fetch data from a specific, like from one single user using variables when we're querying data. And that's amazing. We've dealt with a lot of stuff, done a lot of things, and in the previous episode, I showed you guys how to integrate React as the front end of your app and how to make API queries to your GraphQL API. So we are able to just query by using the UseQuery hook over here, as you can see, and just grab the data. But we can also fetch data on the basis of an event happening. So we use the UseQuery to make that happen. We have a function. When we call the function, we fetch data. So we focus mainly on fetching data and querying data, but what we're going to be doing in this tutorial is going over mutations, which are extremely important because they're the basis of a big part of a GraphQL project. If you recall, if we go to our tab definitions, we do have some mutations over here. For example, we're able to create a user, we're able to update a user, and we're also able to delete a user. So what I want to do is I want to be able to call this mutation over here, create a user, and actually alter the data that we have. And when we take a look over here and we create a user, I want the user to also be listed down here as part of the data. So how do we do that? Well, the first thing we need to do is we need to come to wherever like we have our application, which will be in the display data over here. And I want to clean up this a bit because it's just like this was just for demonstrations in the previous episode, but I'm going to delete all of this. We're going to try to keep it simple. And what I want to do is I want to create over here at the top a button which is going to be called create user. And this will be used to create a user, as you can imagine. And I'm going to create a div to wrap around both this button and also all the different inputs that we need to create a user. What do I mean by inputs? Well, if we take a look at the create user type, it takes in as an input the create user input. And the create user input takes in a name, a username, an age, and a nationality. So what we need to do is we need to take into account that to create a user, we need to ask the frontend to send information containing a name, a username, an age, and a nationality. So for that reason, we're going to come to our display data and we need to create some way so that the user who's like using the website determines what is going to be the name, what is going to be the age, the username, and the nationality. So how we're going to do that is through inputs. And I'm going to create an input for the name. All of them will be of type text, like this. And I'll put the placeholder over here. The placeholder will just say something like name. And I'm going to copy this, I think 3 more times, right? No, it's age, username, nationality. Is it that? Let me see. It's name, username, age, and nationality. So name, username, age, and then nationality. Age will not be of type text because an age is a number. It will be of type number. And this will be username. This will be age. Actually, age. Yeah, just age. And then nationality. So we have our 4 inputs over here, which is amazing, right? You can see that if we refresh our page, actually we don't even need to refresh our page. They already appear over here at the top. And how we actually make it so that whenever we write on these inputs, we get the values is by doing the following. Well, we've done this in the past with this state over here called movie search. We need to create a state that is going to hold in the values for the inputs that we listed up here. So how we do this is I'm going to copy this over here and I'm going to create down over here. To make this seem organized, I'm going to kind of put some comments over here. So for this one, I'm going to put a comment I don't know, create user states. And the first one that we need is a name and a set name. Then we're gonna need also a username, an age, and a nationality. So let me just create two more. This is gonna be username and set username. Then this one over here is gonna be age, and age will be a number, so its initial value will be 0 instead of a string. And set age like this, and then this will be nationality and set nationality. So let me just put set nationality. And what we do is we basically just copy the same logic we wrote down here at the bottom, which is basically the logic for whenever something is written on the input. If there's any change to the input, we want to change the value of the state so that it represents the value in the input, meaning that whenever someone writes on one of the inputs that we created, it will update the state so that the value of the state is equal to whatever the input is. So to do that, we'll just change this to set name over here. Then this over here will be set username. Then this one will be set age, like this. And this one over here will be set nationality. There is a caveat for the set nationality, which is, if you recall, our nationalities in our GraphQL is all in caps ladder, as you can see over here. So the way we're gonna fix this is by coming to our front end over here, and when we have something like the nationality over here, we want to basically match the format of this nationality like variable with how we define it in our GraphQL server. We can actually create an enum in the front end if we want to that matches exactly how our GraphQL enum works over here. However, what I want to do is we just know that no matter what happens, this just has to be uppercased. So I'm just going to come over here, and whatever they write, it doesn't matter if they write it with uppercase letters or lowercase letters, it's always going to uppercase by default by using the function to uppercase. So now when someone writes on this input over here, whatever they write will be translated and set to the nationality state as in all capital letters. So that's how we fix that issue. Now that we are actually saving all of the values of the input and we have our button over here, what exactly do we do? Well, we need to do something similar to a query, which is we need to write some GQL in the front end to make that call. So what we want to do is I want to come over here and I want to create a create user mutation like this, set it equal to GQL, and similar to what we've been doing, I'm just gonna put the backticks over here, and inside of here we want to make a mutation call. So how do we make a mutation call? Well, we just say mutation over here, then we give it a name, and the name will be something like create user. Then we open and close parentheses, and we open and close curly braces, right? Now, the important thing here is we need to take into account that we're going to be passing an input over here. Now, the thing we need to take into account is that we need to pass some sort of input over here. But differently from the kind of inputs that we passed over here, it isn't actually just a variable that is a string. We actually created an input that we pass as the argument of our mutation. If you recall over here, we created the create user input, right? So what we do in this case is we just come over here, we create some sort of variable called, I don't know, let's call it just input to keep it simple, and set it equal to the same name that we passed in the backend so that it recognizes the type. And then instead of this, we want to again say that the mutation we want to call is for the field called create user, which is the field that we want inside of our mutation type. And then we set the input, which is the actual variable that this mutation takes in, equal to the variable that we pass as an argument to this mutation. So we say input like this. And then this over here should return a user, right? Because that's what we determined. And let's just grab the name of the user, maybe the ID as well. And let's test to see if this is working. So we created this mutation. Now, how do we actually use this inside of our React app? Well, I'm gonna come over here. I'm just gonna call, similar to the UseQuery, we're gonna use another hook called the UseMutation hook. And this hook is extremely similar to the UseQuery and to any other hook that we've used so far. You pass over here a function that, like it returns a function that you will be using. So we can call this function create user. And we can also grab the data and everything that it returns, but for now, let's just grab the function. And we pass the mutation or the query that we, like the GQL statement that we created up here inside of this, similar to the UseQuery and the UseLazyQuery. And the thing is, now that we did this like this, and what we do now is we just grab this function over here. We go to our button, which is this one over here, and we just pass an on click to it like this. And we call the function. But since we're going to need to pass some variables to this function, we need to create an anonymous function inside of here, and then call the create user function that we grabbed from the mutation. Then inside of here, we pass the variables, and the structure of the variables for create user is as we did in the backend, right? The first thing we need is an input. So we say input like this, and then for the input type, all we have is a name, which will become the name variable that we created. And since we are actually in objects in JavaScript, I think I mentioned this in the series, when you have two variables that are exactly the same name and they're a key and a value in an object, you don't really need to do it like this. You could just write their name and it's fine. Now we're also going to pass the username, the age, and the nationality. And this over here should technically work. So now that we've called this function over here, we have our button. Let's go to our server over here. I'm going to just refresh the page because sometimes while we're writing, it might give us errors. And then I'm going to come over here. Let me just create a fake person. Let me call it Paulo. Then the username will be, I don't know, I'm just going to write like random letters. And then what else? An age will be 21. And the nationality, let's make it something like, I don't know, Ukraine. And when you click create user, I want to be able to actually make the request. So I'm going to open up the network tab over here. And what should happen is a create user GraphQL request should appear as we click on the button. So when we click on it, you see it appears, but it gave us some error. The first error it gives us is it says input cannot get invalid input of value 21. So it's kind of annoying, but it's cool because it is good to show you guys how to debug, right? So let's for now by default not pass the age. Let's make it so that the age will always be 21. So maybe I'm thinking that maybe the issue is with the input over here and how it's being passed to our GraphQL server. I think maybe this might be a string when it's supposed to be a number. So let's try again. Let me try to submit it. It doesn't matter what we write over here because now it will always be sending 21. When I click on create user, it still gives us an error, but it says that the error is that it got an invalid value of Ukraine when it doesn't match the nationality like enum. And the reason why it doesn't match the nationality enum is because we didn't add Ukraine over here. So let's just do that real quick. Let's add Ukraine, save it. And let's refresh our page. Let me try again with Paulo. Try everything again. So you guys can understand how to debug this kind of errors, right? Age again doesn't matter. And let's try Ukraine again. So when I click create user, you should see that it works. It called a GraphQL endpoint over here, a post request, which in our response, it said that we just added them, the user, right? And what happens is when I close this, right now it doesn't show Paulo over here because it just doesn't show. We haven't refreshed our page. But when we refresh our page, it makes the request again. And now Paulo is over here. And you can see the nationality is Ukraine, which is awesome because now it means that we're actually making the mutation and it's actually working. Now, obviously, if you want to make it so that it will update automatically and you can just add stuff to the screen. There's many ways we can fix this. One way we can fix this is we can actually have in our use queries, when we make queries, we can have something called a refetch. So for example, over here we have query all users, right? And query all users is really cool because it will query our list of users. But the problem is when we add a new user, it won't add to the list. And what we might want to do is we might want to tell our UseQuery hook to refetch the data and query more users when we add a new user to the list. So with this, we can grab a function from a public client called refetch. And now, if I come down here at the bottom, actually no, it's it's down here at the bottom in the button. After we call the create user, what we can do is we can just tell our our use query to refetch more data. And when it refetches the data, it should add the user automatically to our list. So let's make this work. I'm going to add someone else. So let's try putting someone called, I don't know, Felix. Then I don't know, Felix 123. It's hard to come up with names. The age again will be 21, and I'm gonna fix the issue with the age in a bit, but right now it's defaulting to 21. And then nationality, let's just put Brazil like this, and let's hope it works. So right now there's no Felix down here at the bottom. The last one is Paulo, and then we have a list of names, of movie names, because we also did that. But when I click on create user, we should see that it refetched the data, and now we have Felix down here at the bottom. We can keep adding people, and it should keep going. I can add Felix's or whatever, just another user, different age, make it from Canada. I'm going to click create user. The new user should be down here at the bottom. And this is good because it is refetching the data, it's getting more data, it is updating everything in our screen based on the new data in our GraphQL API. Okay, so as I told you guys, my guess was that it was the number, like, right, because this over here, for some reason, the input is being recognized as a text. I always get confused by that, and it should be a number. So right now, what we're getting is we're setting age to be equal to, for example, the number 34 instead of being the actual, like an actual number 34. So we just have to get this 34, which is currently a string, and convert it into a number by passing the number function like this. And we'll do this right when we pass age. So like down here at the bottom, instead of just passing age, we say age is equal to age, but we're going to convert it into a number like this. And if we save now, we come over here, we refresh our page, we try to create someone. Let's call this person Fraser. I'm just reading random names around my room. Then Fraser 456. The age will be 56, and the nationality will be, let's take a look at the nationality that we defined, India. Let's say Fraser's from India. And we create user. You should see that down at the bottom we have over here Fraser. The age is perfectly fine, and Fraser is from India, and it's working perfectly. Now we're able to add users, which is honestly amazing. It means that our mutations are working, and this is basically it for mutations, or in the front end. I definitely recommend using the refetch a lot instead of optimistic like rendering, instead of optimistically changing your states. And what I mean by that is the refetch over here, when you add something to the array, you just refetch the data, right? You add something to the database and you want to see it being displayed in your screen, just refetch it to see the new values instead of actually directly altering the state. Because if I just came over here and I added to our to this data over here, the not the movie data, what is the name of the data? I think it's just data, right? This over here. If I just added the new user to this array over here, it wouldn't be correct because maybe there was maybe some error occurred on the way. So we only are sure that the data is correct if we're refetching the data and getting the data from our API. So I would recommend using this a lot, and we're gonna go over a lot of stuff as well. I'm thinking maybe we have one or two more episodes left, and if you're watching all of this throughout just a single video, which I'm gonna post at the end of the series, just a little bit more, 1 more hour to this course, because honestly, when you get to this point, I feel like it is a lot better to do it on your own. I'm giving you guys a lot of the basics, a lot of the syntax, a lot of the like organization purpose. Actually, I didn't talk a lot about organization. My code is kind of unorganized for now, but I'll go over that at the end of the series. But I'm basically just going over a lot of the basic stuff, and you guys can use what you learned to do stuff on your own. For example, if you want to create a delete mutation, just copy this and post it again, and then change the mutation up here to be to represent the delete mutation that we created in our schema, right? The delete user. So you can try that out on your own, and I think that it will be a great practice for working with this project. I would like to welcome you guys to probably the last episode of this series where I teach you guys GraphQL from the beginning. And the reason why I want to end this series is because I tried brainstorming a lot of different topics that I would add and demonstrate throughout the next episodes. However, every single topic that I ran into was either too complicated in the sense that if I put it in a beginner series, it wouldn't make sense. It would make a lot more sense for me to put it into a intermediate GraphQL or advanced GraphQL series that I might make in the future, or the topics weren't valuable enough or weren't like it didn't have a very common use case, so it would make sense again to add it to this series where I honestly am trying to get you guys to focus on the most important stuff and just trying to make you guys feel comfortable with GraphQL. So I decided that this is the last 3 topics that I want to go over, and I will go over them in this video. So right now we're going to go over 3 different things. We're gonna first go over the different arguments that you can use in a resolver function, so the different inputs that a resolver function might get. We've talked about the args input, but there's 3 more that I haven't went over and I think are important to at least understand. I also want to talk a little bit about fragments and a little bit about error handling and how to use unions to different methods of making cleaner code in GraphQL and how to error handle in a way that is acceptable in the industry. So with that in mind, let's get into the video. Okay, so as you can see over here, we have this query which we've been working throughout our series. You can see that in our, I'm gonna zoom in so you guys can see it a lot better. But in our type definition for our query, we have a query for all users and a query for all the movies. And what I'm doing right now is I'm just making a simple query and I'm accessing and asking for both the list of users and the list of movies, which is something that I can do at the same time. And you should see that the result when I run this is a list with users and also a list with movies. This is something that I didn't show in the previous videos, but you can do it as well. But the reason why I'm using this is because I want to show you guys an example of the different things that we can write in our resolver inputs. So if you recall, each resolver is a function, as you can see over here. And we've been previously, whenever we want to ask for the client or whoever is making the request to send some data, for example, if you're creating a user, you want the client to send the data for the user, right? Or if you're requesting information about a user, you want the client to send an ID. So to access that information, we can access the second argument in this function called args. And I've previously told you guys that to access the second one, there's a first one which is called parent, but it really didn't go over and we really didn't use it. So I will talk about that one right now. And one important thing is, it's not only parent and args, there's actually 4. So the third one that you might want to access is called context, like this, and the fourth one is called info. And all of them have a different purpose. Some are more useful than others, but the important thing to understand is that even though some of them, like info, is rarely used, especially in the beginning, you need to understand its use cases so that if you find yourself in a situation where you might need to use it or might need to access the information about the request, you might use this kind of different aspects of GraphQL. So the first one that I want to go over is parent. So what exactly is parent? So when you access the parent input in a resolver function, it will basically return whatever was returned from the previous level in the GraphQL graph. So I know that sounds weird, but if we really think about it, let me make a comment over here. just to show you guys something. So we have this graph over here, right? This is just a comment. We have over here the highest level, which is the query, right? And below this level, inside of the query, we have, let me go to my type definitions. We have users, we have movies, right? And we have other stuff as well, but let's focus on the users and movies. So for the users, let me just put an arrow over here. We have users, which is a level below the query level. And if we go to the type of user, which is what it returns, there's actually another level, because not only does user return users, but it also returns a movie for the favorite movies. And that's why we do have a resolver individually for user, where we say what favorite movie is, right? So we have this resolver. I explained this, I think it was in the 4th or 5th episode, but we have 3 levels in our users query. So we have favorite movies over here. Now what happens is when we make a query, the parent over here will be undefined, because query doesn't, like this level doesn't return anything. But when we query users, this over here will return whatever we want. So for example, over here, when we're querying users, right? So in our case, it is returning a list of IDs and names. So it's a list with a bunch of objects for each user, which includes the ID and name. So the value that users, the level of users is returning, is this list of user IDs and user names. Now, then we have this over here, which returns a list of the favorite movies, right? This is what we made it happen over here. So the problem is, over here, the parent will be undefined because query doesn't return anything, but in the favorite movies resolver, the parent will be whatever users return. So you're just accessing what the previous level returned. Now, if we had another level over here, another level, so another level would mean, for example, inside of movie, there's some field that returns another type. So that if we had that, then basically we would have to another level will have a parent equal to whatever favorite movies return. Now I know it sounds confusing, but let me just show you. So if we have this users over here, and I access the parent, which is the first argument in the, or the first input in the function resolver function, and I console log this, let's see what happened. I'll open my console log over here, my terminal. You should see everything is working perfectly. If I run this query, it should execute the users resolver, because we are querying for users, and that means that it is console logging the parent, and you can see it is undefined. Now, if I didn't do it in the users level and I did it in the level below it, which is the favorite movies resolver, and I access the parent, you should see that if I console log this, like this, parent, you should see that if I open my terminal over here and I run it again, what it should console log is all of this over here, because it is the return value of the previous level. And you should see that, did it work? Did we actually save it? Oh, we did, like it's working perfectly, but I forgot something. This won't be executed unless we actually specify in the users query that we actually want the favorite movies field. So let's just say that we want the favorite movies field, we want to see its ID and its name. So the ID and the name for each movie that is a favorite movie for this user. So now if we open up a terminal, you should see there's nothing, but if we execute the query, you should see that it returns perfectly. It returns the information about the user that was console logged. Now, one thing that you might have realized is that, well, it isn't exactly what we returned. And the reason for that is because over here, we're returning the ID and the name. Those are the only fields that we asked from the users. But when we access the parents, it returns much more than that. It returns every single field that a user can have. So this is an important aspect of it, and it includes friends, it includes nationalities, it includes age, which we didn't specify in our request. And this can be used for many things. The use cases in our case aren't very valid, but you should see yourself using this a couple of times, especially in a large project. So I think it's important for you to understand at least why it's useful and how it works. So now that we went over the parent argument, we've went over args, we've used it so many times. Let's go over context. So what exactly is context in GraphQL? Well, context, in my opinion, is the second most useful input that you can have in a GraphQL resolver. And the reason for that is because context is useful for many situations, including authentication, authorization. Also, if you're using some sort of library that, or some sort of API that will communicate with your resolvers, and you need to have that quick access to different variables and functions and classes inside of the resolvers. And you'll understand why. Basically, context allows you to pass variables, numbers, whatever values throughout every single resolver. So if we have a value or a variable that is useful throughout every single resolver, for example, some sort of authentication method or some sort of token, we can pass it through the context, and every different resolver function will have access to that value by accessing the context. Let me give you an example. To create and pass information through the context variable, we need to come to our index.js, and where we declare our instance of our Apollo server over here, we need to add a context property over here. And context is a function like this that returns an object. So in our case, I'm going to open this up a bit so you guys can see it better. At the end, we need to return an object, and it can be whatever we want. Just as an example, let's imagine that we want to have access to an object with a property called, or key called name, with a value called Pedro. So we have a user who has been logged in throughout the application, and their name is Pedro, right? And we want to have access to that name throughout every resolver. We can pass this as the return statement for our context. And if we come to any different resolver, for example, let's do it for the user's resolver, and we come over here and we write all the previous inputs until we get to context, and we console log the context. Let's see what is console logged. So console log context, let's open our terminal up. You should see nothing is console logged, but when I execute a query that queries users, it should console log whatever we returned in our context object over here. So you can already start seeing why this might be something important, because we can use this for many situations, including and most importantly, authorization and authentication. Another example of why this might be useful is, imagine if you're using an ORM for a database system, right? So many people use MongoDB. So if you have a MongoDB model that you want to have access in every resolver, you can pass them over here, like user model, and I don't know, just access it throughout the resolvers without having to import them in every single file. You just access them in the context, right? And that's cool. That prevents unorganized code, and it's useful in various different situations. Now, one thing that I wanted to point out is a lot of people get confused in regards to like things that can be done in normal Express, in normal REST APIs, and how to do them in GraphQL. One of the things is accessing the request information, like the rec object that every request has in Express. So you can actually do this with GraphQL by passing this rec variable inside of the context. So to access a request object for every request, you can just pass it as the argument to the context function by grabbing it like over here, and you can pass it inside of here. You can say rec, and you're returning the request. Now, if I come to my resolver and I console log my context again, like I've been doing, you should see that when I run this, it should console log information about the request, and it includes everything, right? It includes the GraphQL like query, what we wrote, the type of method, the status code, if it worked, if it didn't work, even like the information about the computer you're using, right? So it's really interesting because a lot of people are confused by this, and this is how you can do something like that. This would be very useful, for example, if we were passing headers to our GraphQL API for some sort of authentication authorization method. If we said context.rec.headers, for example, in our case, we're not passing any headers in the front end, but this is how we would access, because if I execute this query, it should say the headers for the request, which in our case is this, but we didn't pass anything like specific. We didn't pass any tokens, anything like that. But I just wanted to show you guys exactly how you would do something like that. Now, this is context, and it's really useful. It's more useful than parent, in my opinion, and than info, which is the next one we're going to look at. So keep in mind and understand it fully. You can play around with it and do different examples just so you can get a better grasp of exactly what you can do with it. Now, let's talk about the last input you can grab from a resolver function in GraphQL. And I won't spend a lot of time on this one because, to be honest, I don't think I've ever used it in a actual situation. This argument is the info input that you can get. And I'll just console log it so you guys can see what it is. If we console log the info and we execute the query, you should see that this is what it console logged. It's just some information about the GraphQL request. It's not exactly like a rec, like we just console logged, because it doesn't include a bunch of methods and stuff related to the request individually. It is very like funneled towards the GraphQL aspect of the request. So for example, it gives you the field name, which is users. It gives you like what exactly it is. It is a query. It kind of gives you the schema as well, some validation errors if you had any extensions, any descriptions you put. It specifies exactly how the type is. So specifies everything from our schema over here. And it is interesting just to take a look at it. I don't find many use cases for it. In the beginner level especially, it's somewhat useful and when you're doing some more advanced stuff. But for now, let's just keep it like this. You won't be using this a lot. I just had to go over it because I didn't want you guys to not at least like have an idea of what it is. So this was info, and this were the 4 different inputs you can grab in a resolver function. Feel free to use them whenever you want. They are important and they will be useful in different use cases. So just knowing how they work and what they're used for is important, so that if you find yourself wanting to use one of them to solve some sort of problem, you can at least know that they are part of the problem solving, the solution, right? So now that we went over this, let's go over another important topic in GraphQL that I wanted to talk today, which is fragments. So what exactly is a fragment, right? It's kind of weird to explain, and the use cases might not be as useful in the beginning, but I would say that fragments are mostly used for like organization purposes, for maybe reusing code in the client, so that you don't have to keep copy and pasting the same code 1,000 times, right? And what happens is in the client you can actually impose limits to fields that you're querying in a query. So what do I mean by that is, imagine that we want to query our list of users, right? So I want to delete this over here, and I want to query our list of users. But imagine all I want to see from these users, for some reason, I'm in a page of my website where all I need to see is the name and the age, right? I need to specify that, and whenever I use this query again, I don't want to have to put down these fields again. Now, it's only 2 fields, but imagine that users may have a lot of different fields. Like many websites have some important type, like users include a lot of stuff, because a user in a website can include many different fields. And you don't want to keep having to write all the fields again. What you can do is you can kind of specify what these fields are inside of a fragment. And it's almost like, the analogy I like to make is almost like setting the fields equal to some sort of variable and reusing the variable, so that you don't have to list out the fields that you want from this type ever again. And it also imposes a limit, because you can't add stuff to the fragment after it's created. You can query other fields on top of the fragment, but that doesn't matter that much in our case. Let's just get into how do we create the fragment. So what we do is we just write inside of our client, not in the backend. We specify, I want to get a fragment, I want to give it a name. So let's call it get age and name. It's a horrible name for a fragment, but let's just call it like that. And we need to specify which type is this fragment going to be based on. So this fragment will represent fields from the type user. So we can say this, we open and close curly braces, and then we specify which fields we want to get to query from user, which in our case is name and age, right? So let's just put both of them over here. And what we need to do now is when we make some sort of query that uses these fields, this specific fields, what we can do is we can just say ... and then specify the name of the fragment, which is get age and name. And you should see that when I run this, it will query only the age and the name. And if I add more to this, like the nationality, it will automatically understand, and it will query all of this. Now again, this is mainly used for reusability, and it's really cool. I like to honestly use it. I use it sometimes for specific types like user, because it usually includes a lot of stuff. So feel free to use them how many times you want. They are created in the front end, so you got to keep that in mind. And yeah, that's basically what fragments are. So it's a pretty small topic. Now I want to really talk about some more type of advices that I would give to someone working with GraphQL on how to make their code look better for industry standards. In the sense that, like, how do you error handle specifically? How would I error handle in GraphQL? It's something that I learned in a previous job that I had, and I feel like it's very useful, and it is one of the best ways to error handle, because it provides you with a lot of insight on how to work with GraphQL and how to think of GraphQL as graphs, which is one of the main points of GraphQL. So what I'm talking about is error handling by using unions and result boxes. And what I mean by result boxes is basically whenever we have a mutation or a query, we want for its return type, for example, let's go to our query over here. This query over here returns a list of users, right? But the problem is, what if there's an error? And what if there's a specific error in our API or in our database that we're not seeing over here? Well, GraphQL specifies primarily errors related to GraphQL. So like, for example, you put instead of an ID when you make this query, you put a string or a boolean. GraphQL will recognize that and will return an error. But what if there's an error making a request to our database, or there's an error making a request to an external API? Well, GraphQL won't really give that much information about it, so we need to do that ourselves. But how would we error handle in this case? Well, what I like to do, and what I learned is one of the good standards in the industry, is you can basically create a union between this return type, which is what we want, so the successful return type, and the error. Now, how would we create this union, and how would we actually make it work so that we are returning either one of those things, right? So basically what we want to say over here is, for this user's type, or this user's field, we don't want to return this. We actually want to return a union of two different things. One thing will be this result over here, and the other thing will be some sort of error if it occurs, right? So what we do is, we can create over here at the bottom a union and call it something like user's result. Now, to create a union, you just write the union keyword, and you write the name of the union. Then you set it equal to two different types in GraphQL. Now, it must be types. It can be scalars. It can be arrays or whatever. It needs to be a type. So this is kind of a problem for us, because the successful return type for our user is an array of users, right? And the problem with that is that we need to make another type which includes this as one of the fields. So this is how we would go around this. I would come over here and I would create a type over here called users successful result. I know the name is horrible, but just bear with me. This is the type, and inside of it, it has the type users, and it returns this over here, which is what we want to return from this. So we put it inside of here, and we say that this is the successful result from querying a list of users. Now, this can now be used as one of the options in the union, right? It can either be this or some sort of error object, some sort of error like that is returned from our API. Now, for that to happen, we also need to create the error type. So I'm gonna call this users error result, and it's a type, and inside of it we can put how many things we want, but let me just put a message which represents the error message from this request, right? Or from this query. So the type of message will be string, and I'll make it required as well if it eventually happens. So now we can say that this user's result is a union between the user's successful result and the user's error result. So the way we make a union in GraphQL is we keep separating the different results that we can have by putting this vertical line over here. Now we have these two types merged together that can be both representing the result from our user's query. So now instead of just coming over here and saying that users return users, we're now error handling because we say that users can return users result, which can either be an error or the array of users. Now, how do we handle this? Because it is important to understand that right now we're not doing anything related to the user's error result. It just exists, but we're not actually, if there's any error, what exactly do we do? Well, the way we do this is by basically we're going to come to our resolvers over here, and you recognize that we created a new type called user's result. So what we have to do is we need to actually create a new resolver field for the user's result. So I'm going to come here down at the bottom, and let's just create a new on top of the mutations type and on top of the users type, there's another type which is on the highest level, which is called the users result type. So users result, like this. And this over here will include, in our case, only one resolver, and that resolver will resolve for both cases, for the success and for the error. So remember what we had over here, this this resolver over here for users. It's kind of not as useful right now because we don't have the return type is not this. It is actually a union between two different things. So we need to focus on this resolver down here at the bottom, which will resolve and we'll check to see if there was any errors or if there wasn't any errors. And the way we do this with unions is actually, it's a bit different. A resolver and for a union uses something called a resolve type, which is basically like a different type of function which you can use from Apollo, which allows you to specify what is being returned and which of the two options from the union are actually being returned. So from it, we can access something called an object, which will allow us to see the fields that are returned from our original resolver over here. So what we're going to check inside of this resolver is the following. We're going to check if user list is equal, it exists, then we want to return the user list, right? So basically, it's almost like if user list was our database. So we were querying from a database. If there's no errors, if it actually returns the list of users, which is what we want, then return this. But if it doesn't, then it will come down here at the bottom, and we'll get to a point where this wasn't true, so it should return an error. So what we're going to return is an object containing, let's think about it. It should contain a message, and the message will be, yo, there was an error. And by the way, this over here is wrong right now because if you recall, we changed the type for our union. Our union doesn't return just a list of users. It returns a type called user successful result, which is an object containing a users field, which then returns a list. So instead of just returning users list, we need to return an object containing a field called users, which is equal to user list. And if this is confusing, which I know for a fact it might be, I just need to tell you guys to relax. This is a complicated topic. I definitely didn't get it first time. I'm just pointing this out so that if you need to reference in the future, watch it a couple times, practice on your own so that you can actually understand everything. And don't worry if it seems confusing in the beginning. But basically, we're returning now either this, which is the first option, or the error, which is the second option. And we need to know if which one of them were returned inside of our user's result resolver. So the way we know which one was returned is over here we can come and say that basically if the object that is returned has a field called users, then we know for a fact that it is a user, right? It was correctly returned, so like it was successful, so we can just return the actual object.users that we received. We're just saying, okay, if there was no errors, return the whatever we received from our resolver above. And if if it doesn't have that, then we just know it was an error. So what we want to return is we're going to return the object.error. So object.message, right? The object.message. So these are the two things we want. And the way we specified this and the way we tried this is let's open this up over here. We have our API running. Let's try querying for the users again. I'll just specify that I want the ID, the name, and the age, right? It's giving us some errors, and the reason why it's giving us some errors is because we changed the return value of users. And this is something extremely important. You can see that the return type for users now is users result. So how do we specify in the front end what we want from querying a union? Well, the thing is, when you query a union, there's two different options, right? There's two different things that can happen. A user successful result or a user's error result. So what we do is we need to specify what we would want, like each field that we would want, depending on which case is returned. So in the case that it returns a success, we can put 3 dots and say on user result, not user error, but user successful result. So if there's a success, then we want to grab the ID. We're going to grab the, actually it's not, then we want to grab the users field, which is inside of this, and the users, we want to grab the ID, the name, and the age. I know this is confusing, but basically what we're saying is if the result was successful, then we want to query the users from the result, and for each user we want to grab the ID, the age, and the name. Now if it wasn't successful, and if it is the case that it actually returns a user error result, by the way, it can only return one of those two types, or else GraphQL will just give an error saying that it returned a wrong type, right? And if this is the case, then what we do is we basically say that we want to grab the message, and this is it because message is a string, is a scalar type, it's not an object like users, so we can just grab the message individually. So now this is how we would form it, and if we added more stuff to our union, we could add more of this over here. So when we run this example query, you should see that it must resolve to an object. It gave us an error, and this is the message that we received. Now the reason why we received this message is because of the following. I actually made a mistake here. The return for when you're resolving a union is not exactly the result that you want to return back. You need to specify which of the options occurred, right? So for example, we called in our union resolver over here. It can either be of type user successful result or user's error result. So what we return in our union is, for example, if the object.users exist, then we know that it was the user successful result because users doesn't exist in the other type. The other type only includes the message field, so we know it was an error if the message field exists. So what we do is we actually return a string containing the name of the union type that occurred. So in our case, if it was successful, the option out of the union was the user successful result, so that's what we return over here. Then we do the exact same thing but for the message. So we just put if object.message, then we know it was an error, and we just copy the user's error result over here and paste it down the bottom. Now what happens is, if none of those are true, then it was a GraphQL validation error or any sort of GraphQL error that occurred. So we can just return null in this case because it will know that it was a GraphQL error instead of an error that we predetermined based on some sort of API call or some sort of database call, something like that, right? So when we have this done, we can just come over here, open this up as well, and try to run this, and you should see that we get back our data. We get back data, users, a list of users perfectly, because what we did is we said that if the list of users exist, then return a successful result, right? But if it doesn't, then return an error. So let's see the case in which it doesn't. So the analogy we would make here is if there was an API error. So we made an API request for the user list, but we didn't get that data. What would happen is the following. I'm going to come over here to where we define our data, which is over here. It's in the fake data.js, and I'm just going to delete this over here. I'm actually going to set this equal to null, like this, just for a second, so we can see what would happen. So users list shouldn't be existing. So when we run this query, you should see that we get back an error type. It says abstract type users result, and it gave us an error message, but it isn't the error message that we wanted. It says abstract type user result was resolve a type users errors results. Oh, okay. I think I put it. Yeah, I put an s at the end over here when it shouldn't be. As you can see inside of our type definitions, it doesn't have an s at the end. So when we run this again, you should see that it recognizes there was an error that we determined. So it gives back a message saying, yo, there was an error. But if we go back to our fake data and we put back the data, you should see that it actually returns the data instead of the customized error message that we created. And yeah, guys, that's basically it. If you got to this point of the video, I hope you watched the whole series, and I hope you gained as much value as you could. Again, if you have any questions, feel free to leave them down below, especially in this video. I'm going to be answering all the questions you guys have. I was really excited to make this series, and it was one of my best experiences because GraphQL is one of the topics that I'm most interested in, but I also find it one of the most difficult ones to actually get it. And especially in the beginning, it is one of the cause of many doubts and many problems to beginners. So I really wanted to make something that I feel I would have enjoyed if I was the one learning GraphQL right now. So if you feel like you gain any value from it, I want to ask you guys to leave a like down below and comment what you want to see next. Subscribe and turn the notification bell as well to see all the videos that I post. I would be very happy if you could do so. And yeah, that's basically it. Comment down below what you think about the series, and I'm really happy that you ended up watching the whole video. And yeah, that's basically it. Really hope you guys enjoyed it, and I see you guys next time.